So hello and welcome back. Now in this video we will talk about units and unit conversion. And well, this is the same thing that we had basically in the NCERT book. Let me show you an example here. Okay, so we had a section in the NCERT book. As you can see, we had basically large numbers in practice, and then over here we had basically how to measure, for example, the length of a pencil, the width of a the width of a book or notebooks basically. And so essentially we are talking about measuring things, right? So essentially you have a pencil which is something like this. So let's say that, for example, this is a pencil, and the length of the pencil is essentially this, essentially the distance from here all the way up to here. Okay, that's basically the length of the pencil. Or essentially the width of of a book, for example, would be essentially, for example, something like this. So you have essentially something like this. And then basically there is, and then the book. So this is essentially the back of the book. This is the back cover of the book. This is the front cover of the book. And then this width over here is sometimes, for example, if it's a thick book, then it's, for example, at 1 centimeter, or essentially 2 centimeters, or 3 centimeters, or something like that. So essentially what we do essentially with units is that we use them in order to measure things. For example, measure the length of a pencil, or essentially measure essentially the length of a road, for example. Measure the length of a path, for example, from your home to school. Measure for example, the weight of some object, for example, anything like that, basically, right? Now over here we have basically, so we have essentially, we want to essentially do things like this. For example, measuring the length of a pencil, the width of a book, a notebook, and then we use essentially some unit in order to do that. Now we will see essentially what units are. For example, a unit would be a millimeter, a centimeter, a meter, again a centimeter, millimeter, or essentially kilometer. Or for example, over here we have another unit which is a gram, or a milligrams, or a liter, or a milliliter, or something like that. So these are all units. And then the exact same thing, essentially we use them in order to solve different practical problems. Meaning that, for example, we have a bus, for example, starts its journey from some place, some point A, for example, over here, and then it goes to point B, and then goes to point C and D, and so on and so forth. And then the distance between A to B is, for example, so many kilometers, 4,000, for example, 170 kilometers, which is, again, kilometer is basically a unit, basically, that we use in order to measure essentially a distance, basically, between 2 points, basically. The distance between B and C is, again, for example, so many kilometers. So then using these units, then we can essentially solve different problems. Or for example, for money, we have essentially for money or currency, we have again our own units. For example, in India we have the rupees. In, I don't know, in the US we have the US dollar. In the Europe we have the euro, and so on and so forth. So that's again the basically rupees, or US dollar, or Canadian dollar, or for example the euro. These are again units for currency, or essentially units for money, basically, right? And you can see that essentially for objects, we don't use a unit, we just count it, and we say, for example, let's say that, for example, I have 1, 2, 3, 4 pencils in some place. Then I can simply count them, essentially the pencils 1, 2, 3, and 4, and then I can say 4 pencils. And then I have, for example, notebooks, then I can say, for example, 3 notebooks by counting them, and so on and so forth, right? And then all of these units essentially can be used in order to solve all of these different problems. For example, the number of bicycles that we sold, the difference between the number of bicycles and then the number of copies of a newspaper, and then so on and so forth. So essentially all of these are linked together. And then we also went through exercise 1.2, in which we had all of such problems. You work with the numbers and you also work with the units in order to solve problems successfully, right? So that's a simple thing. But the first thing that we need to understand here is essentially what is essentially a unit and where it originally comes from, right? So unless you understand essentially what the unit, essentially you know what a number is, right? A number is basically a well, when you count essentially the number of something. For example, I have some objects over here, for example 1, 2, 3, 4, 5 pebbles, for example. I have these 5 pebbles over here, and I can count the number of pebbles, and you know already what counting is. I can say 1, 2, 3, 4, and 5, and then essentially this 5, for this 5 we have a number which is essentially a 5, and then I can say that I have basically 5 pebbles over here. So that's counting. And then essentially once you have the number, you already can do different operations on your number, meaning that you can add numbers together, you can subtract numbers from one another, you can multiply numbers together, and you can divide numbers together. And using essentially these 4 operations, you can do different things with your numbers, basically, right? So that's essentially all about numbers. But then what is a unit? So basically a unit is something that you use in order to measure the amount of something, basically, or something like that. Let me give you an example so that you understand what I mean. Suppose that, for example, my mother tells me that give me, for example, suppose that she has a recipe and she wants to make the recipe, she wants to cook some sort of food, and for this recipe she needs essentially a small amount of rice, for example. Now in order to and essentially usually in the recipe it says, for example, add 200 grams of rice, 200 grams. So essentially the 200 is a number, and the gram is basically the unit that you use in order to measure the amount of rice that you need, right? Now suppose that this unit didn't exist, right? And so then there would be no way essentially to specify the amount of rice. And then my mother would have to tell me, for example, give me, I don't know, a handful of rice, for example, right? Now the problem with this is that essentially a handful of rice is different for different people, because essentially different people have essentially hands of different sizes, basically. My hand might be a little bit larger than your hand, somebody else's hand might be a little larger than my hand, and so of course there is no standard for the size of a hand, because everybody's hands are just simply, they have essentially different sizes, basically. And so the amount of, for example, rice that I can keep in my hand will of course be different from the amount of rice that somebody else might keep in their hands, right? And so then basically there is going to be a problem, meaning that essentially my handful is going to be different from somebody else's handful basically. By the same logic, essentially, if you were to measure the distance between, for example, these two, for example, let's say that this is a point, for example, this is one point, this is in front of your house, and this is a couple of meters away from this point. And you want to know essentially what is the distance between these 2 points. Essentially a way to measure the distance is by comparing it to the length of your foot, meaning that you put 1 foot over here and then another foot over here, another foot over here, and so on and so forth. And then you might say that, for example, this distance is, I don't know, for example, 12 feet, for example. Feet is the plural form of foot, basically, right? Meaning that when you put essentially 12, 1, 2, 3, 4, and so on, and all the way up to 12 feet over here, this whole distance can be covered, and then you call it essentially 12 feet. But then again, this type of measuring has the problem that my foot length is going to be different from your foot length, and that in turn is going to be different from somebody else's foot length, and so on and so forth. So then there is no standard foot length, because everybody's foot length is going to be, of course, different. It's something natural, basically, right? So then essentially in all of these examples, when my mother tells me that give me a handful of rice, then of course there is no way that she can be certain how much rice she's going to get, right? And then again, if I go to the store and tell the shopkeeper, give me a handful of rice, for example, or give me a little bit of potatoes, give me a little bit of tomatoes, or something like that, then of course there is no way to know what is a little bit, or essentially what is a handful, right? So the shopkeeper gets confused, I will get confused, and then he doesn't know how much to charge me for, I don't know, for the amount of potatoes, for the amount of tomatoes, for the amount of rice, and so on and so forth. And so this way, essentially, there's going to be confusion in the whole world, essentially, because now today, essentially, we have global. Essentially, everything is bought and sold basically globally. Something is bought from some part of the world and then sold in a completely different part of the world, and so then there is going to be confusion all over the world if there is no standard unit essentially to measure essentially all of these things, right? And now suppose that essentially when my mother wants to ask me to give her essentially a handful of rice, suppose that there was one single person in the whole, I would say, in the whole world, I would say. Suppose that there was one single person in the whole world, and whenever I wanted to measure, for example, a handful of rice, I could go to that person, I could have him measure that handful of rice for me, and then give me that handful, and then I could give that handful to my mother, right? And then if anybody else needed, again, a handful of rice, they could go to the same person and ask the same person to give them a handful of rice. So then this way, anybody in the world that needed a handful of rice could go to the same person, and then everybody would get the same amount of rice from the exact same person, right? And even the shopkeeper, when the shopkeeper, essentially when I asked the shopkeeper to give me a handful of rice, the shopkeeper again could go to the exact same person and ask that person to give him a handful of rice, and then he would give me the same amount of rice, and then everything would be essentially, and then there would be no problems, no confusion, nothing, right? So over time, essentially what people have done is that essentially because there has been this kind of confusion in essentially in trading things among people, then people have basically have gradually come towards basically and come towards internationally accepted basically units based on which everything can be measured, right? Meaning that, for example, when I want to basically measure a distance, for example, between 2 points, for example, I want to measure a distance between 2 buildings, for example, I don't use my I don't use my foot, I don't use somebody else's foot, I don't use essentially my cousin's foot length or anything like that. I know essentially one single person in the whole world. Whenever I want to essentially measure this distance, I will go and bring that person to that spot. I will have him essentially measure that length for me, and then I would say that essentially this distance is, for example, so and so many, for example, foot lengths of the person that we all know, right? Now, this one person that we all know essentially in the whole world, and whose foot length we are using essentially as an internationally accepted unit, is, for example, the meter, right? We have essentially found a person in some place in the world, and everybody knows this person. And for example, we have essentially taken the foot length of this single person, and then anybody who wants to measure something, they go to the exact same person, whose foot length, of course, is not going to change ever. And then, for example, the foot length of that person, we have called it the meter, and then now everything that we want to measure, we will compare it with the foot length of that person. For example, I want to measure this distance over here. I put his foot length over here. I say, because this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, and this is, for example, 8.5. So then this is going to be essentially, this distance is going to be 8.5. Essentially 8.5 of these standard foot lengths, and so I call it, for example, 8.5 meters, for example. Now this way everybody in the world essentially will understand what I mean essentially by 8.5 meters, because they all know that it's 8.5 times the foot length of that person, basically, right? Or, for example, in order essentially to measure, for example, the mass of something, for example, you say that one kilogram of potatoes, or for example, 1 kilogram of, for example, of tomatoes, 1 kilogram of rice. These are essentially different ways to measure essentially the mass of different objects, basically, or different basically vegetables, basically. Now suppose that there is this one person in the world, and this one person, for example, suppose that this one person has essentially a big stone, basically, right? Now I take essentially the mass of this stone as everybody in the world can take essentially the mass of this, and this stone essentially remains with this person. Nobody is supposed to detach essentially the person from his piece of stone, or from his rock, basically. And then everybody who wants to measure something, they will go to this person, and then they will compare the mass of whatever it is that they want to measure with the mass of this stone over here. For example, I have essentially an amount of rice, for example, and I want to know essentially what is the mass of this rice, right? So I take my rice essentially to this person, and then we will somehow compare the mass of this rice and the mass of the rock, basically. So we could, for example, use one of these balances, which you could, for example, you could build a balance like this. You could essentially have a balance like this, and then I put the stone over here, and then I put the rice over here, and then this way we can essentially, I can compare essentially the mass of the stone, or essentially the mass of the rock, to the mass of the rice that I have. And then I could say that, for example, the mass of the rice is, for example, 3.5 times the mass of the stone. And then if I, for example, if I call the mass of this stone as, for example, 1 kilogram, then the mass of the rice would be 3.5 kilograms, right? And so now this way, essentially, everybody knows what is meant by 3.5 kilograms. Everybody will think that, well, when he's saying 3.5 kilograms, that must be essentially 3.5 times the mass of that stone that this particular person has, and now essentially I know what he's talking about, right? And so in the exact same way, there have been essentially different base units essentially in the world. So we have essentially we have a standard for the meter, which has been defined in physics in a very accurate way, meaning that it's essentially the length that light is going to cover in so many seconds, basically, meaning that you have to measure time, and then you have to measure essentially, and then you have to use light, and then the distance that light covers, for example, in some fraction of a second, is going to be called essentially the meter. Although in the past, basically what we had was just a simple rod, and then the length of that rod, for example, was taken as a meter, for example. But then, of course, there's going to be accuracy problems with just a rod. Of course, it's nothing that can compete with, for example, with the case where you measure time, for example, very accurately, and then you use light, and then light is going to essentially cover a certain amount of distance, basically in a vacuum, in a very accurate fraction of time, and so then that length has now been taken as a unit, basically. Or, for example, for the kilogram, exactly in the exact same way in the past, somebody in, I suppose it was in France, many 100 years ago, somebody in France had a rock, basically, a rock, or essentially a piece of essentially metallic object or something like that. And then that mass was taken as, for example, as 1 kilogram, but of course you know that that sort of thing cannot be very much accurate. I mean, it could change. I mean, the mass could change over time. It could rust. Many things could happen to this standard. So then now essentially kilogram has also been defined in physics based on mass of atoms, basically. And so now there is no way that the mass of an atom essentially can change under normal conditions, of course. Then there is the second, and time is a little bit tricky, but then time has also been defined based on some processes, based on some processes that you could later on study in physics. The second has also been essentially meaning the amount of time that goes by, that can also be defined very accurately. And then for the electric current, we have the ampere, which is again which has again been defined very accurately. So these are essentially our fundamental units: the length, the mass, the time, and the electric current, right? Now based on these fundamental units, every other unit in physics will be essentially can be derived, meaning that, for example, I don't know, for example, work in physics is based on, force and some other quantities in physics. And so essentially when you put a couple of these units together, you can define, for example, the amount of work, the amount of power, the amount of any other thing that we have in our universe. We can define all of those units essentially based on these fundamental units, and then we call them derived units. Okay. And then essentially, if you want to read over here, although we will essentially in physics we will get to all of these, you can essentially go to openstacks.com or org, if I'm not mistaken. You can go to openstacks.org. openstacks.org, and then you can basically over here you could go to, for example, science, and then over here you could find physics, chemistry, physics, and then there is the physics, college physics, for example. You could get this book, which is College Physics 2nd edition. And then in this is essentially the exact same book that I'm using here. And in the first chapter of this book, essentially all of these units have been essentially very clearly, they have been explained very clearly. Okay. So that's basically all about that. So we have the meter, we have the kilogram. So the meter essentially is the these are essentially the units of time, length, and mass. So the unit of time is the second, the unit of the length is the meter, and the unit of the mass essentially is the kilogram. Okay. Now there is essentially just one thing that is also important here, and we'll have to talk about that as well. Okay, so far basically we have these three units that we are going to essentially use in our work everywhere we go. And basically the three units that we have, these are essentially the fundamental units. Or essentially you could call them basically the fundamental quantities. And essentially the fundamental quantities are basically length, and basically you have the mass, and you have the time, basically, right? So for the length, the unit is the meter, which is essentially written as a lowercase m. For the mass, the unit is a kilogram, which is essentially written as a lowercase k and lowercase g, right? And the unit for the time is the second, which is written as a lowercase s, right? And you already know essentially what is a meter. A meter is, well, you already know what that is. It's something very close to a yard, for example. A yard is a little bit less than a meter, basically. And you know what is a kilogram? A kilogram is, well, you know essentially what is a pack of potatoes, what is a 1 kilogram pack of potatoes, for example. Or essentially what is a kilogram of, for example, tomatoes, or a kilogram of rice, or something like that, right? You are already familiar with all of these things intuitively because you have worked with them. And essentially for the time, you know what a second is, and you know essentially that, for example, if you put 60 seconds together, you'll get a minute. And you know what a minute is, you already know it on your watch, hopefully, of course. And then when you put essentially 60 minutes together, for example, you know that you'll get an hour, and you know essentially what an hour is, basic. That's essentially the duration of time. We are already familiar with all of these things, right? Now all of these things are based on something that we call a system of units, which is very important. You need to understand it in order to understand many things when it comes to units. So what is a system of units? A system of units is essentially, well, a system that tells you essentially what to do in that system with these units, meaning that based on a particular system of units, essentially for the length, you will take essentially the unit is the meter, the unit for the mass is the kilogram, and then the unit for the time is the second. In some other system, all of these might be different. Again, there might be many different systems around the world, different basically conventions by different people, by different groups of people, and essentially all of these are different basically systems of units, basically, right? And of course there are many systems of units all around the world, many of which are not really official ones. For example, if you go to if you go to a tribe in Africa, they might have their own system of units, basically, which is used only by them and not by anybody else in the world, basically. It's just a system of units that is used by these tribe people in Africa, which is something local, basically, right? Now, among essentially all of these systems of units that have survived from the very beginning of time, I would say, from essentially since many thousands of years, there have been different systems of units essentially all over the world for different purposes, but then essentially now two of them have survived. One of them, well, I should actually say three of them have survived. There is essentially one system of units, which is the SI system of units, which is essentially accepted all over the world for scientific purposes. Okay. There is another system of units that is called essentially the imperial system of units, and this system was originally born in the United Kingdom, and then since essentially since different parts of the world were different nations essentially were once ruled essentially by the British Empire, their system of units was essentially inherited by these different people, basically. And so, for example, the US was once ruled by the British Empire, and so essentially the British system was inherited by the US people, basically. And so essentially this system that originated in the British Empire, that's essentially called the imperial system of units. Okay, but then when there was independence in the US, or essentially sometime around that time, basically, the US people, essentially what they did, essentially Americans, what they did is that essentially they made some changes to this system, and then another system was born, which is now essentially called the customary system of units, which is used only essentially in the United States. Okay, so now we have the customary system of units, which is essentially something which is essentially whose origins essentially come from the imperial system, but then there are some changes made to the imperial system, and then as a result the customary system of units is born. But essentially when you do things in mathematics, you usually essentially in mathematics or essentially in science, you usually just simply use the SI system, right? Meaning the imperial system or the customary system. Of course, if you live in America, basically, of course, you need to know about the customary system, meaning that, for example, if you live in France, for example, normally the SI unit is used for everything. So when you go to shop, you would ask for a kilogram of rice, for example. But then in the US, for example, when you go to shop, you ask for a pound of rice, basically. A pound is basically, for example, somewhere around half a kilogram, for example. So when you live in the US, of course, you need to know about the customary system of units. Or essentially, if you live in the in the United Kingdom, of course, you need to know about the imperial system, which is again, for example, in the UK, for example, you would ask for a pound of rice, for example, right? But then again, as long as we are using, essentially, as long as we are using units in mathematics or essentially in science, in chemistry, in physics, and that sort of thing, we usually, essentially, we always use the SI units. Okay? But of course, in physics, you are supposed essentially to know the imperial system as well, or essentially the US system as well, because essentially you need to, I mean, when you talk to engineers or usually engineers essentially in the US or essentially from the UK, you are supposed to be able to understand what they're talking about, because they are using different systems than the SI unit. And also essentially you're supposed to be able to convert these different units to the SI system back and forth, which is essentially something that we will do later on essentially in physics. But right now, essentially in mathematics, we will just simply use the SI system. Okay, so that's essentially again something that you need to know about. Now essentially now we know essentially essentially all the different units in the SI system that we need for now, which is for the length we know that we have the meter, for the mass we have the kilogram, for the time we have the second, and we know that essentially we have these mainly three systems in the world that you need at least to know about right now. We have the SI system of units that we use in mathematics and essentially all the problems that we solve in mathematics. We have the customary system of units, which is used mainly in the US, and we have the imperial system of units, which is mainly used in the UK, basically. Okay, but these two essentially we are not going to use right now. Later on we will use them in physics. Okay, now there is only one problem here that we still need to solve, and then we can essentially move on to the rest of our work here. And that is essentially measuring basically very, very small and very large quantities. Okay, and for that essentially you need to use essentially the metric prefixes or the SI system prefixes. So this is again very important for our work here. These are called the metric prefixes or the SI system, prefixes. Okay, and what that is, essentially a prefix is used, well, that's essentially a prefix is a pre, which essentially is something that comes before something, and then you fix it to something else, meaning that you fix, for example, you have something over here, and then you fix something to the beginning of that thing, right? For example, you have, for example, let's say that, for example, the time duration is, for example, 12 seconds, right? But then there is a prefix, for example, in the SI system. You could say instead of 12 seconds, you could have another time in duration, for example, 12, for example, milliseconds, right? You could say, for example, 12 kiloseconds. You could say 12, for example, microseconds. So the milli, the kilo, the micro, these are essentially these prefixes that we are talking about here, right? And essentially the purpose of these prefixes is to is essentially the following. Let me give you essentially an example so that you understand it. So suppose that, for example, the length of a route, there is a route that goes from, for example, one city, or essentially a path goes from one city to another city. If I take essentially for the length, if I take the unit as, if I take essentially the unit as the unit for length as the meter, for example, and then if I take a mirror stick in my hand, and then if I keep measuring that path 1 meter, 2 meter, 3 meters, 4 meters, and so on and so forth, I might come up, for example, with a number like 25,000 meters, meaning that essentially the distance between those two cities is 25 times, basically the 25,000 times basically the length of our unit, which is essentially 1 meter, right? So that's 25,000 meters basically. On the other hand, suppose that you want that through some process or through some technique, basically you measure, for example, this is the distance essentially between two cities, right? Now suppose that you measure essentially the diameter. Suppose that you measure the diameter of an atom, for example, and suppose that that's essentially for example something like, for example, 0.000000001 meters, for example, right? You measure essentially the diameter of an atom, which is going to be, of course, a very, very, very small distance, and that's going to be 0.000000001 basically. That's a 9 and a 10. Let's make it essentially, put the 1 over here. That's essentially 6. No, I'm sorry. So that's a 0, 0, 0. That's a 9 and a 10, for example. Something like this, for example. And that's again in meters. So this is, of course, this is a very large distance. That's 25,000 meters, meaning that you can imagine a mirror stick. Essentially, if you multiply the length of a mirror stick by the number essentially 25,000, that would be the distance that's essentially between the two cities, because essentially the two cities are very far apart from one another, basically, right? And the diameter of the atom, since it's a very small distance, it's going to be 0.00000000001 meters, meaning the meter stick, you would break it into essentially you would divide it essentially by a 10, by 1 billion. So essentially the meter stick, you would break it down into 1 billion equal distances. So the 1 meter divided into 1 billion, and of course 1 billion is a big number, of course, right? Very large number. Divide the whole meter stick into 1 billion equal distances, and then one of those tiny equal distances, when you take that would be essentially the diameter of an atom, for example, some atom, just for the sake of this discussion, right? So then this is again essentially very large number. This is going to be a very small number. Or for example, some other large number would be essentially something like 25, 0, 0, 0, 0, 0, 0, 0, 0, 0, and 0, 0, 0 in some unit, basically. 25 and, for example, 12 zeros in front of it. Or essentially some number. So essentially, you see that when you want to write down these numbers, you are going to need essentially to use basically, I don't know, 10, 12 zeros after the decimal point, or 10, 12 zeros after the numbers, and so it's going to be very untidy, and it's not going to be very easy to essentially to do anything with these numbers, right? So then, to solve these kinds of problems, essentially what you can do essentially these metric prefixes, or the SI system prefixes, meaning that instead of saying, for example, 25, and that's I don't even know what that is, but for example over here, for example, for example, this number would be essentially a 25 billion. Or essentially this number would be essentially 25 trillion, right? And this number would be one, or if I make it, for example, if I make it something like this, that would be essentially a 1 billionth, for example, right? So now this number could very easily be essentially be written as, for example, 1 into 10 raised to the power negative 9, for example, right? 1 into 10 into 10 raised to the power negative 9, in the essentially using essentially the scientific notation, which we will talk about later on in physics, basically. But then essentially you see that you have the decimal point over here, then you have 3, 6, and 9 essentially decimal points, and the 9 essentially comes from here, right? You have the 9 decimal points, so you would write this as 1 into 10 raised to power negative 9, and negative 9 means that essentially when you have the negative 9, essentially the negative sign, that means that essentially you have all of these digits essentially after the decimal point, meaning that the number is very small, basically, right? And essentially you have 3, 6, and 9 basically digits after the decimal point, and so the 9 essentially comes from there. Or essentially this number over here, you could write it as 25 into 10 raised to the power, for example, 1, 2, 3, 4. 4 into 3 is 12. You can write it like this. Or you could write it as 2.5 into 10 raised to the power 13, for example, right? This is called basically the scientific notation. Again, it's not important right now what that essentially what that actually is supposed to do, but then what we have done over here is that 10 raised to the power 13 is actually essentially so many zeros and a 1. Essentially 10 raised to the power 13 is actually nothing but essentially a 10 and then 12 zeros, or essentially a 1 and then 12 zeros, right? So this is 10 raised to the power 13, and then if I multiply essentially 2.5 by this number, I will get to this number, which is essentially very easy way essentially to represent this number with essentially so many zeros in front of it, right? Or essentially this number, when you want to read it, you would have to say 0.000000001, or essentially you would have to say 1/billionth, right? But then in the scientific notation, you would just simply write it as 1 into 10 raised to the power negative 9, right? Now for these, basically for these parts over here, 10 raised to the power 12, 10 raised to the power negative 9, for these essentially coefficients, we have names essentially in the SI system, and the names are essentially simply like this. So we have basically, for the very large numbers, you see over here, we have this table, and in this table essentially you have 10 raised to the power 0, which is equal to 1. This is essentially when no number is multiplied by anything. And then essentially when essentially when you have 10 raised to the power, for example, 3, 6, 9, 12, 15, 18, or essentially you could go in the other direction, you could go in the negative direction, 10 raised to the power negative 3, negative 6, negative 9, negative 12, negative 15. For all of these instances, we have created all of these different prefixes. For example, the 10 raised to the power 1 has been called essentially a deca. These are usually essentially Latin or I mean, these words usually come from the Latin language or essentially from the Greek language. So a 10 raised to the power 1 has been called deca. A 10 raised to the power 2 has been called hecto. 10 raised to the power 2 is 100, meaning 1, 2 zeros. A 10 raised to the power 3 is a kilo. For example, we say a kilogram, right? Or a kilometer. That's a 1, 10 raised to the power 3, that's a 1 and 3 zeros in front of it. 10 raised to the power 6 has been called the mega. And then when you want to write essentially a deca, you would write a DA. When you want to write a hecto, you would write a lowercase h. When you want to write a kilo, you would write a lowercase k. To write a mega, you would write an uppercase M, and so on, and so you can go all the way up to mega, giga, tera, peta, and then exa, which is 10 raised to the power 18. And then over here, basically, we have the, essentially, you can go in the other direction. You can essentially say that, for example, for 10 raised to the power negative 1, which is 0.1, essentially 0.1 basically, that would be essentially called a deci. You would write it as a D. 10 raised to the power negative 2 would be 100th, which is 1 over a, essentially 0.01 basically, right? Which is called essentially a centi, which is, you use a lowercase c for this. For 10 raised to the power negative 3 is essentially 1,000th, which is 0.001 basically, which is essentially called a milli. And then in the exact same way, we have micro, nano, pico, and femto, and atto. And atto is then 10 raised to the power negative 15, meaning that this is a very small number basically. You can make it very small numbers using this, meaning that you have 0.0000000, which is 3 times, that's 9 zeros, and then another 000, which is 12 zeros. So for example, an atto, which you would write as a lowercase a basically, as you see here, that's a 10 raised to the power negative 18, which is essentially nothing but 0.000000000, that's a 000, that's a 4 times is equal to 12, 15, and then 001, right? That's a 1, 2, 3, 4, 5, 6, 6 times 3 is equal to 18. So then if you have this very, very small number, right, you could write it as 1 into 10 raised to the power negative 18, right? Which is the same thing as essentially 1 atto, and let's say that this is in meters, for example. The diameter of a very, very, very essentially tiny atom, for example. This is in meter. Then you could write it as 1 into 10 raised to the power negative 18 meters, which is the same thing as 1, and 10 raised to the power negative 18, we saw that it's essentially an atto. So I could write it as an atto meter, and the same thing I could write it as 1 atto meter, 1 am, right? So this way, essentially, instead of writing this very large and long number, I could just simply write 1 atto meter, right? And now essentially we can very easily do conversion with these numbers. Essentially, given the fact that we know what is essentially a kilo, 10 raised to the power 3, we could set up our proportions very easily, and we could do conversions with these numbers without any problems. The only thing that you need to know here is that for now, you do not really need to know. Essentially, sometimes a couple of these you need to know. When the time comes, essentially, we will talk about them. There is no need to memorize. And you need to know essentially the kilo, or sometimes, usually the kilo, basically the milli, you need to know in order to work with, or essentially the centi sometimes. These things, essentially, when you know that, for example, the meaning of a kilo is 10 raised to the power 3, meaning 1,000, or when you know that essentially a centi is 10 raised to the power negative 2, or essentially a 100th, basically, then when you know essentially what these are, then you can just simply set up your fractions and proportions, and then do all kinds of conversions without the need to essentially memorize or remember anything. Okay, so this was all about the unit conversion. Now, how you do essentially the conversion with these units later on, if we get to some exercise, now we have this base and foundation, and then we will use it in order to solve all kinds of problems, basically. So I'll see you in the next videos, and thank you. Okay, so now welcome back. Now in this video we will talk about estimation, which is very much related to essentially to rounding numbers. So we will talk essentially talk about both of these over here. Now, about estimation, essentially what that is that basically you have, for example, in the news, sometimes you hear about something. For example, India drew with Pakistan in a hockey match watched by approximately 51,000 spectators in the stadium and 40 million television viewers worldwide. So approximately 51,000 spectators in the stadium, or essentially approximately 40 million television viewers worldwide. Or basically approximately 2,000 people were killed and more than 50,000 injured in a cyclonic storm in coastal areas of India and Bangladesh. Or basically over 13 million passengers are carried over 63,000 kilometers route of railway track every day. So these are essentially all estimate numbers, basically. These are all estimations, meaning that, for example, the actual numbers over here was most probably, basically, when you say, for example, 51 spectators, that could have been 51,000, for example. That could have been 51,000, for example, 235. It could have been, for example, 50,863, or essentially any number between the two numbers. So these are essentially all approximation. And you do this approximation for the sake of simplicity in your numbers, meaning that, for example, a person that is watching the news, they don't usually care about the exact number of people that watched essentially the match in the stadium. They just want to they just need a ballpark number, basically, a rounded number, meaning that they don't care about 51,235. They don't want to know the exact number. Just a 51,000 would be more than enough information for them, and more details essentially they don't need to have, basically, right? So in such cases, essentially in cases like these, you would basically approximate. Basically, you would do approximation in your numbers. And again, for example, and that's essentially the kind of situation where you would essentially approximate your numbers, right? Now let's take the example of now let's take a look at essentially approximation, the concept of approximation in the first place, and then we will see essentially how we can essentially demystify it, meaning essentially to make it essentially open, so that you can basically approximate your own numbers and essentially round your own numbers and do the whole thing essentially yourself. Now the number of spectators that we had essentially in this case was, for example, it was written as 51,000, basically. Okay, now let's make the assumption that the actual number of spectators was, for example, a 51,265, for example, or let's make it essentially a 63. Let's say that this is the actual number of spectators in the stadium, and then this number essentially was rounded essentially to 51,000 for the sake of simplicity. Okay, now if I have this number over here, which is essentially a 51,263, and if I want to, now I can essentially, in order to do the estimation, I can round the number in many different ways. I can round the number essentially to the nearest tens, basically. And if I do if I round the number to the nearest tens, then basically I have the 51,263, and then basically and then essentially to the nearest tens, basically. So this is the tens place value, which means that essentially all of these digits all the way up to the tens place value, I care about all of these digits, but then essentially the last digit in the number, I just don't care about it. So then, for the sake of simplicity, I'm going to substitute it with a 0, basically. So I'm going to put a 0 over here, and then I'm going to write the number as 51,260, right? So that's essentially the same number rounded to the nearest tens, essentially, right? Or basically the same number, or essentially that's the same number, 51,263, if I were to round it to the nearest hundreds, for example. Then what that means is that I have 51,263, and the nearest hundreds would be, this is the tens and this is the hundreds place value. That means all the digits in the number all the way up to the hundreds place value, I care about them, but then these two digits, I simply don't care about them. I want to essentially substitute them with zeros for the sake of simplicity, right? And then I will write my number as a 51,300, and that's essentially my rounded number, essentially to the nearest hundreds, basically, right? Now, if I have essentially the exact same number, the 51,263, and if I went to round the number to the nearest thousands, for example, then what that means is that essentially 51,263, that's the thousands place value. So I will basically, all the digits in the number, including the thousands place value, those are the digits that matter to me. But then the rest of the digits, I'm going to just simply substitute them with zeros. And so then basically then I will write my number as a 51 and then 3 zeros. That's a 51,000 basically, right? So as you can see, as I round the number more and more information is being lost in the number, meaning the number was a 51,263, and then the number essentially when you round it to the nearest tens, it becomes a 51,260, then it becomes 51,300, then it becomes 51,000. So you get essentially more and more zeros in the number, which means that essentially more and more digits in the number are being just simply substituted with zeros, meaning that more and more information you're essentially losing in the number. Okay, and then basically if I were to the exact same number, essentially, which is 51,263, if I were to round it basically to the nearest 10,000s, then basically I have my number 51,263, and you want to round it to the nearest 10,000s. This is the 10,000s place value, which means that essentially only this place value is important to me in the number. The rest of the digits are going to be just simply substituted with zeros, and then I will write my number as a 50,000. And so then basically the only digit that remains in the number is essentially a 5, and then followed essentially by 4 zeros, right? But then now the question is essentially based on what am I making these changes to the number, meaning that essentially in this case I keep the 1, the 5, the 1, the 2, and the 6, and then I lose the last digit over here. Over here I keep the 1, I keep the 5, the 1, and then the 2 becomes a 3, but then the last 2 digits are dropped. In this case, essentially, I keep the 5 and the 1, but then the last 3 digits are simply dropped. In this case, I keep the 5, and then the last 4 digits are simply dropped, right? And basically, to answer this question, we can essentially take a look at these numbers essentially on a number line. So if the number is a 51,263, and if I were to round the number to the nearest tens, essentially, what that means is that essentially all the digits all the way up to the tens place value I'm going to keep all of these digits, and then the rest of the digits I'm just going to discard, right? Which means that essentially this number is then going to be essentially some number between 51,260, right? So I already discarded the last digit, all the way up to 51,270, for example, right? Because I have essentially some change over here. So then it could be essentially 51,260 all the way up to 51,270, right? So again, the last digit in the number essentially has been substituted with zeros, right? And then on a number line, you can see that suppose that essentially that's a 51,200. Let's say that this is a 51,260 and 61, or essentially 60, 61, 62, 63, 4, 5. So that's a 51,000. That's a 51,265, 6, 7, 8, 9, and that's a 51,270, for example, right? And so then this is a 51,261, 2, and 3. So this number over here is a 51,263. And you can see that that essentially, if I were now, I need to make a decision here. So if I were to essentially to drop the last digit in this number, meaning essentially substitute the last digit with a 0, I have essentially only two options here, which is either 51,260 or essentially 51,270, right? Now, in order for this number to be the best representation, essentially, in order to find essentially the best representation for this number in terms of essentially any of these two numbers, so of course the number that I pick must be some number essentially which is essentially closest to essentially to any of these two numbers, meaning either essentially I'm going to pick essentially either this number or this number, because that's the only two options that I have. But then I need to decide whether the actual number is closer to this one or closer to this one, right? So of course you can see that essentially the distance between these two numbers is only 3 units over here. So I have only 3 units, and I have essentially 1, 2, 3, 4, 5, 6, and 7 units over here. So of course the number is much closer to this number. So then I'm going to take this number as the rounded version of my original number, and then I'm going to say that when I round the number 51,263, it's going to be a 51,260, right? So that's basically that's essentially rounding the number to the nearest tens. Now, the same number that we had over here, 51,263, if I were to round it to the nearest hundreds, then what that means is that essentially the same number, I'm going to pick essentially the hundreds place value, which is this place value over here, and of course I'm going to keep all the digits all the way up to the hundreds place value, but then the rest of the digits I'm going to just ignore and basically substitute them with zeros, basically, right? So then you can see that that of course this number is 51,263 is some number between 51,260, meaning that this number is supposed to be between 51,260 and to the hundreds place value, I should say actually it's some number essentially between a 51,200, right? Between 51,200 and essentially a 51,300, right? And of course, you know that 51,263 is actually a number between these two numbers, right? Now, the only question is essentially whether this number is actually closer to this number or closer to this number, which you can essentially see on the number line. So if I go essentially to the number line, and if I go essentially, if I say that this is 51,200, and this is 210, 20, 30, 40, and 50, so this is 51,250, 60, 70, 80, 90, and this is a 51,300, right? This number over here. And the actual number that we have over here is a 51,263. So this number over here is a 51,260. And 63 would be essentially this number over here. So this number over here is a 51,263. And you can see that this number is of course much closer to this number, right? Is much closer to this number, which means that I'm going to take essentially this number as the rounded version of this number. I'm going to write it as a 51,300, right? So you see that over here essentially the 2 was actually augmented or incremented to a 3, and then basically I got the 0 over here, I got the 0 over here, and then the number becomes a 51,300, right? And you can just keep going with the same thing. So essentially the only thing that matters here and which is important is that when you, for example, when you have the same number over here, for example, the same number, 51,263, and when you want to round it, for example, to this time to the nearest basically thousands, for example. So essentially what we have been doing so far is that essentially you take your number 50, you take your number, whatever that is, and you want to round it to the nearest thousands, which is this place value over here. So you want to keep essentially all of these digits, and you want to essentially, and the rest of the digits you want to just simply substitute with zeros, right? But then essentially at the same time you want to decide whether essentially this number is essentially closer to essentially a 51,000 or essentially a 52,000 basically, right? Because if I were to write this number again over here, if I were to write this number over here as some number between a 51,000 basically and a 52,000, then you want to decide whether essentially this whole number is closer to 51,000 or essentially to 52,000. Whichever one is the case, then you will take that number as the rounded version of your number, and then you will write it down basically, right? Now, so essentially you know that between essentially 51,000 and 52,000 there is the difference essentially between the two numbers essentially is 1,000, right? And here I have only essentially 263, right? Or essentially over here I have essentially only 263. So if I have essentially a number line over here is a 51,000, and essentially over here is a 52,000, and if the difference between these two numbers essentially is 1,000, then right between the two numbers is the difference essentially is a 500 difference basically. So you have essentially a 500 over here, a 500 over here. 500 plus 500 makes essentially 1000, right? So then essentially you have to go to 263. You have to start from 51,000 and go all the way up to 263 over here. You get all the way up to here, and then basically, and then of course your number is going to be right over here, right? And then of course this number, since it is to the left hand side of the 500, it's going to be much closer to this number over here, which means that essentially the rounded version of your number is going to be a 51,000, right? Now if you didn't understand this, it doesn't matter. There is another way that you can think of this. You see over here again, you have your number essentially goes from 51,000 all the way up to 52,000, meaning that the number that we have over here has to be essentially some number between these two numbers, right? And then you have a 2 over here, and this 2 is actually, that means this is actually a 2 groups of 100, which is essentially 200, right? And the difference between these two numbers is 1,000, right? So essentially you would have essentially 200, 400, 600, 800, and 1,000. So which means that essentially this number, since essentially from the 51,000 you move only somewhere around essentially 200, and at most essentially at 300, not more than that, then of course your number is going to be much closer to the beginning, which means that essentially then again the rounded version of your number is going to be a 51,000, right? Now if I don't want to calculate the place value over here and write it as a 2 times 100 and so on and so on, and do all of these calculations in my head, what I can do is that, so the 2 that I have over here, if I think of the essentially, if this was essentially a 1, that would be essentially one group of 100, which is essentially 100. If this was essentially 2 groups of 100, this would be essentially 200. If this was essentially 3 groups of 100, this would be essentially 300, and so on and so forth, all the way up to essentially 9 groups of 100, which is essentially 900, right? So then essentially you have all of these numbers over here, 1, 2, 3, 4, 5, 6, 7, 8, and 9 basically, right? So which means that essentially if you go all the way up to 4, you're still closer to the 51,000. If you get to 5, you're at the same distance from 51,000 and 52,000. And if you have any of these digits over here, 6, 7, 8, and 9, you're much closer to the 52,000, right? So now in this case, since essentially I have a 2 over here at the 100 place value, that means that I'm just simply essentially much closer to the 51,000. So then I'm going to essentially write my number as a 51,000, right? Now let's take the same number, 51,263. 51,263. Now let's suppose that I want to round the number to the nearest tens basically, right? Now which means that essentially I want to keep essentially all of these digits including the tens place value, and I want to discard this digit over here, right? So then basically my number is going to be essentially some number between essentially 51,260 and 51,200 and essentially 51,270, right? And well, then again I will take a look at the digit to the right hand side of the tens place value. So this is the tens place value. Again, I will take a look at this digit over here. So this digit means essentially 3 groups of 1. So then you have 1 group of 1, 2 groups of 1, 3 groups of 1, and so on and so forth. If you go all the way up to essentially you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, right? If you go all the way up to 4, you're much closer to this number. If you go, essentially, if you have a 5 over here, you're essentially exactly halfway between this number and this number. And if you go essentially all the way, all these digits over here, you are essentially much closer to this number over here, right? And if you have a 0 over here, if this was actually a 0, then what that means is that you are you're exactly at this number, right? So then based on the digits that you have, so since essentially this digit was actually a 3, so that means that essentially you're much closer to this number over here, and then you would write your number, the rounded version, as 51,260, and that's essentially your number, right? So now what you have done is that you have written exactly essentially 5126, and then you have essentially substituted this last digit with a 0, right? Now let's take a look at essentially, now there were essentially 2 cases over here which need essentially some explanation again. And those 2 cases are essentially if the digit is actually a 5 or essentially a 0, right? So let's now swap our number with a 51,265, for example. And I want to again round to the nearest tens basically, right? So which means that essentially I want to keep all of these digits including the tens place value, and I want to substitute this with the 0. So which means that essentially your number must be some number between 51,260 and 51,270. And well, again, basically since this digit is a 5, that means you're exactly halfway between these 2 numbers, right? Which then essentially makes it not very easy to choose, essentially, because essentially so far what we have been doing is that whichever number is closer to your number, you're going to pick that number. But then since you're equidistant from both of these 2 numbers, then basically there is no way to choose. And then so then in such essentially in this particular case where the digit is actually a 5, by convention you're going to have to essentially to go for the higher number, meaning that you're going to round up basically, okay? You're going to round up, and you're going to make the assumption that your number is essentially closer to this number over here, and then you will write your number as 51,270 basically, right? And then if your number was basically, if you had the case with the 0 over here, 51,263, 51,260, and then let's make it a 0 basically, right? Now again I want to round this number to the nearest tens, which means that I want to keep essentially all of these digits all the way up to the tens place value, including the tens place value, and I want to substitute with this digit, whatever it might be, with a 0, right? Which means that again your number is some number between 51,260 and 51,270 basically, right? Now, because of the fact that you have a 0 over here, that means that you're exactly at this number. And of course, since you're exactly at this number, you are of course closest to this number, which means that you're going to pick the same number and write it as 51,260, right? So then essentially in all of these cases, what we have been doing is that essentially we have been looking at the digit to the right hand side of the digit to which you want to round the number. I will explain essentially what this means. Let me delete this. And so far essentially our number, let's say that it was 51,263, and if you want to round your number to the nearest tens, for example, then basically you don't, I mean, as long as you have understood the concept, then you don't need to consider essentially all of those things, like for example your number so essentially in this case I want to round the number all the way up to the tens place value, and then the rest of the digits are going to be essentially zeros, right? But now, as long as you've understood that the concept, you don't have to consider all of those things, that for example your number is supposed to be some number between 51,260 and 51,270, and then and then basically now I will take a look at the digit to the right of the tens place value. Now if this digit is a 1 or a 2 or a 3 or a 4, I will round down. If it is a 5 or a 6 or a 7 or an 8 or a 9, so again over here we said that essentially if you have any of these digits, you're going to be much closer to this number, so then you're going to round up. And then if it's a 5, by convention again you're going to round up, and if it's a 0, then again you're exactly at this number, so again you're rounding down. So essentially then, as a rule, we can say that if we have to the right of the tens place value, if we have the essentially a 0, 1, 2, 3, 4, we are going to round down, and if we have a 5, 6, 7, 8, and 9, we are going to round up, right? Now what do I mean by round up or round down? Basically rounding down, that means that essentially you just don't need to think about essentially any of these numbers. You can just simply forget about these. Of course, again, as long as you have understood the concept. Your number is 51,263, and you want to round all the way up to the tens place value, right? You take a look at this digit over here to the right hand side of the place value, and then you see that it's a 3. So the 3 over here you're going to round down, which means that you write your number as 512, and then the 6 remains a 6, right? And then the 3 is substituted with a 0, right? So then the number, essentially the rounded number, becomes basically a 51,260. Now suppose that your number is a 51,267, for example, right? And again you want to round to the tens place value, so all the way up to here. Again you will take a look at the digit at the take a look at the digit to the right hand side of the tens place value, and then you see it's a 7, right? The 7 over here, essentially when you see the 7, you have to round up. Rounding up, that means that essentially you will write your number as 5126, and then this 6 over here has to be incremented by 1, which becomes a 7, and then this 7 essentially becomes a 0. Then your number essentially becomes a 51,270. And then it's just simply in accordance with what we considered before. We said that essentially this number has to be some number between 51,260 and 51,270, and then depending on this digit, you know essentially whether your number is closer to this number or to this number. If it's closer to this number, you're going to pick this one. If it's closer to this number, you're going to pick this one, right? And so you saw that, and then over here basically you can see that 51,263 is of course closer to this number, so I'm going to pick this number. And 51,267 is of course closer to this number, so I'm going to pick this number, right? But then again, you don't need to, as long as you've understood the concept, you can just simply forget about this. And then depending on this digit, if it's a 0, 1, 2, 3, 4, you're going to round down, meaning that essentially the tens place value remains as it is, and then you will fill this place value with a 0. And then again over here, basically again you take it, look at this digit over here to the right hand side of the tens place value. If it's a digit like 5, 6, 7, 8, and 9, you're going to round up, meaning that essentially the tens place value is incremented by 1, which means that the 6 becomes a 7, and then the ones place value is filled with a 0, and then the rest of the digits are going to be written as they were. So 51,270. That's basically how you would essentially round your numbers, basically, right? So hopefully I haven't made this concept more complicated than it needs to be. In the next video we will go through a couple of examples, exercises, and I'll see you in the next video. Thank you. Okay, so what we have next here is a couple of exercises and some material that we can now work with. Essentially, in the previous video, we have understood the concept of rounding and basically and estimation, and now we can understand essentially what's on this page basically. And so basically, for example, if you have essentially all of these numbers, 261, 263, 267, 269, the numbers on which you have essentially these flags, then basically if you were to round these numbers to the nearest tens, meaning essentially the tens place value, meaning the 6, the 6, the 6, and the 6, and the 6 in all of these numbers, you would just simply, you know that essentially either if you think of 261, 63, 65, 67, and 69, these are all numbers essentially between 260 and 270, right? And when you and then basically for example 261 is closer to 260 than it is to 270. So then if you were to round this number to the nearest tens, then you would round down, and then you would essentially end up with a 260, or essentially 263. You can see that it is much closer to 260. Again, you would round down to 260. On the other hand, 267 and 269 are much closer to 270. 267 and 269 are much closer to 270. And so then you would round up, meaning that the tens place value in each of these numbers is then incremented by 1, which means that the 6 becomes a 7, 270, and then in the ones place value you would essentially put zeros basically. So that would be 270 and 270 for both of these numbers. Now for this number, essentially for the numbers 10 and 17 and 20. So if you were talking about essentially 10, 17 and 20, on a number line, basically we will have essentially a 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. And the number 17 is right over here, right? Now the number 17 on this list, the number 17 here is essentially much closer to 20 than it is to basically to 10, right? So then in order to round this number to the nearest tens, then you would have to round up, right? Meaning that essentially the number 17, the tens place value over here, you will increment it by 1, which means that the 1 becomes a 2, and then the 7 becomes a 0. So then you would have essentially a 20, so which means that essentially 17 is rounded up to a 20. Whereas, for example, a 14, for example, because it's much closer to a 10, then you would round it down to 10, which means that essentially a 14 is rounded to a 10 basically. And then, as we discussed before, a 15 is essentially, it is at the same distance from 10 than it is from 20 basically, right? So then by convention, the 15 essentially you would essentially round it up to a 20. Now again, if you take a look at the number 15, and if you want to round it to the nearest tens basically, and if you don't want to essentially bother about the number line and essentially all of those things, what you will do is that you will take a look at the digit to the right of the tens place value, and you want to round actually to the tens place value. So you will take a look at the digit to the right hand side of the tens place value, which is essentially a 5, this digit over here. And the 5 essentially, again, it is at the same distance from 20 as it is from 10. So the distance is the same. Now by convention, essentially when you have a 15, you would round, when you have a 5 essentially, you would round up, which means that then basically you would, rounding up, that means the tens place value is incremented by 1, which becomes a 2, and then you would put a 0 in the ones place value, which means that 15 is then rounded up to a 20 when you essentially round to the nearest tens basically, right? So that's basically all about these numbers. Now on this number line you can see that 12 is again between 10 and 20, of course, and it lies, and however 12 is closer to 10, so then you would round down to 10, which means that essentially a 12, when you round essentially to the nearest tens, it essentially becomes a 10 basically. And that would be, of course, correct to the nearest tens basically. Now there is something interesting here, and that's about the numbers 1, 2, 3, 4 and 1, 2, 3 and 4. On a number line, essentially, let me take a look at it. Let's take a look at these numbers. So on a number line that goes essentially from 1 to 10 basically, so you have 1, 2, 3, 4, and 5, 2, 3, 4, and 5, 6, 7, 8, 9, and 10, right? So you can see that essentially on this number line, the numbers essentially 1, and let's essentially include 0 over here as well. And we have essentially these numbers 1, 2, 3, and 4. This number, this number, this number, and this number. These are much closer to 0 than they are to 10 basically, right? And so then of course a 1 is rounded down to 0, a 2 is rounded down to 0, a 3 is rounded down to 0, and a 4 is rounded down to 0, right? On the other hand, these numbers basically 6, 7, 8, and 9, because of the fact that they are much closer to 10, they are rounded up to 10. So a 6 is rounded up to 10, a 7 is rounded up to 10, and 8 is rounded up to 10. Also 9 is rounded up to 10. And then basically you see that a 5 is at the same distance from 10 as it is from 0 basically, right? So the distance between 5 and 10 and the distance between 5 and 0 are exactly the same. So you have basically 1, 2, 3, 4, and 5 units here, and then you have 1, 2, 3, 4, and 5 units over here. So then by convention, basically the number 5 is again rounded up to a 10, right? So now if we were to round these numbers to the nearest tens basically, what we could essentially take a look at some of or a couple of them. So we want to round essentially to the nearest tens basically. To the nearest tens, and so essentially 28. A 28 essentially is much closer to 30 than it is to 20. So then the 28 is rounded up to a 30, right? And you can, I mean, if you don't want, I mean, when the number gets a little bit large, then basically, and this is easy because you want to round to 10, so you have only essentially a couple of digits over here, so it's not that hard to think about the situation. But essentially these numbers get complicated when you have some number like, for example, 28,625, for example, and you want to round to the nearest tens, for example, which is this digit over here. So then basically you can still think of this number as 28,625, and then 28,600 you can just keep it essentially aside. So you have a 28,600 and you have a 25, and 25 rounded to the nearest tens essentially you would round up to a 30 basically. So then you would have essentially you could then essentially add these numbers together, meaning a 28,600 plus a 30 would be 28,630, for example. You could think of it this way, right? If it makes it easier for you. Otherwise, basically, when the number gets large like this, a 28,625, and you want to round it to the nearest tens, again, you can just simply take a look at the digit to the right hand side of the digit to which you want to round the number. Meaning that over here I want to round the number to the nearest tens. So looking at the digit to the right hand side of it, which is the ones place value, I can see that I have a 5 over here, and we saw that essentially a 5 is by convention rounded up to a 10 basically, right? So when you round this digit to a 10, then basically you have 10 groups of 1 over here, which means that essentially one group of 10. 10 groups of 1 is the same thing as one group of 10 basically. So one group of 10 would be, you would essentially bring this one group over here, so this 2 essentially becomes a 3, and essentially then these 10s essentially I have used them over here, and so the number becomes essentially 28,630, and then the ones place value becomes a 0 because you're rounding the number basically. Okay? Because you're rounding the number, the ones place value becomes a 0, and so your number essentially becomes again a 28,630. Or if you don't want to, I mean, whenever you're in doubt, of course you can consider all of these 10 groups of 1, one group of 10, and then essentially bring the groups over to the different place values. But then again, essentially if you have a 28,625 and you want to round to the nearest tens, you would just simply take a look at the digit at the, and of course this is provided that you understand the logic behind what you're doing, meaning that this is provided that you understand essentially, that you know essentially what you're doing. You take a look at the digit to the right, which is the ones place value, the 5. When your digits are essentially anything like a 5, a 6, a 7, 8, and a 9, you would essentially round up, right? This you can use as a rule everywhere. This you can use as a rule everywhere, again provided that you understand what you're doing, right? And then basically if you have any digits like 1, 2, 3, 4 and a 0, then you would round down basically, right? So now the digit is 5, and the digit 5 is essentially by convention, essentially in the case of digit 5, since the digit 5 is equidistant from both the ends of the two numbers that you have, then by convention you would round up. Or essentially whenever you have a 5, a 6, a 7, 8, or a 9 at this place value, then you would essentially round up, meaning that essentially the tens place value you would increment it by 1, it becomes a 3, and then the ones place value becomes a 0. So then you would again get a 28,630. Anywhere, essentially any method that you use, you will of course come up with the same number. Again, for example, the number 32, right? The number 32, when you want to round it to the nearest tens, so of course number 32 is some number between 30 and basically 40. And of course 32 is much closer to 30. So you would round down to 30, right? Alternatively, what you could do is that you could essentially consider the same number 32 and you want to round to the nearest tens. So then you would take a look at the digit to the right hand side, which is a 2. And so since in the case of a 2 you would round down, then you would essentially write the 3 as it is. Rounding down means that essentially the digit to the left is not supposed to be incremented, right? It remains as it is. And then essentially this 2 over here becomes a 0. So then the number essentially becomes a 30, the same number that we got over here. For example, a 52, when you want to round to the nearest tens, then basically you know that the 52 is some number between 50 and 60 basically. And since 52 is much closer to 50, you would round down to 50 basically, right? Again, alternatively, what you could do is that essentially a 52 rounding to the nearest tens, you would take a look at the digit to the right is a 2. So you're rounding down, which means that essentially this digit, essentially the tens place value is not going to be incremented. So you keep it as a 5. and then basically and then essentially the ones place value becomes a 0, so you'll have essentially 50. Again, a 41, for example, is much closer to 40 than it is to 50, so you would round to essentially 40. A 39 is much closer to essentially to 40 than it is to 50, so then you would round it to essentially to a 40. A 48 is some number between 40 and 50, and you're rounding to the tens place value. So since it is much closer to 50, you would round to 50. Basically a 64 is some number between 60 and 70, and so since it's much closer to 60, then you would basically round to 60. A 59 is some number between 50 and 60, and it is much closer to 60, so you would round to 60. A 99 is some number between 90 and 100, and since you're rounding, essentially since it's much closer to 100, you would round essentially to 100. A 215 is essentially a number which is, you're rounding essentially to the tens place value, so it's some number between 210 and 220, right? And since it's halfway, exactly halfway between the two numbers, then by convention, and since essentially we have a 5 over here, then by convention basically you would round up, meaning that you would essentially round up to essentially to 220, right? Now again, I have to emphasize the fact that basically all of everything that you're learning over here, there are many places that these things are going to be used, okay? I mean, you might not be aware of it just yet, but for example, in computer science, essentially computer science is nothing but just numbers and numbers and numbers. And well, clever ways to essentially to use numbers in different ways in order to do different things essentially with computers. In computer, basically, in computer programming, well, computer science and computer programming are, well, of course they are very close, really close, but again they are two different things basically. But again, in computer programming, you're always dealing with numbers, okay? In electronics, in basically in again in mathematics, meaning that if in the future you're essentially planning to study essentially a master's in mathematics, essentially an undergrad course in mathematics, a grad course in mathematics, a PhD in mathematics basically, again, all of these are going to be used over there in any branch of essentially engineering, like the mechanical engineering, the electrical engineering, that sort of thing. So these are super important things, and essentially they are important in the sense that when you learn these things properly, then you're going to be very good at whatever you do in the future, meaning basically you're going to be very good at understanding computer science or any branch of engineering or electronics or mathematics or wherever you go. So you want to make sure that you understand all of these things before you move forward essentially in all of these things. So then again, basically over here we have a 1453, and we want to round to the nearest tens basically, right? So that's a 1453. which means that essentially it's some number between 1450 and 1460 basically, right? And of course it's much closer to 1450, so I'm going to take this number. Alternatively, since you're essentially rounding to the tens place value, you will take a look at the digit to the right, which is the 3. And as we saw, essentially in case of 0, 1, 2, 3, and 4, you will round down, meaning that this digit remains the same, and then this digit becomes a 0. So then you would have 1, 4, 5, and 0, which is essentially this number over here. Or essentially a 2936. Again, over here, you're rounding essentially to the nearest tens, and so again this number is a 2930, some number between 2930 and 2940 basically, and it's much closer to this one. So then I'm going to round it up to 2940. And again, alternatively, what you could do, you could say that basically that essentially you take a look at the digit to the right, which is 5, 6, 7, 8, or 9, which means that essentially you're rounding up, right? Rounding up means that this digit becomes a 4 and this digit becomes a 0. So then you would have 2940, which is the same number over here, right? So that's rounding essentially to the nearest tens basically. Now let's move on to basically rounding numbers to the nearest hundreds. Okay, so rounding numbers basically to the nearest hundreds is the same procedure basically. For example, when you have essentially 410 and then basically you want to round it to the nearest hundreds basically, so that the hundreds place value, the hundreds place value essentially in this number is the 4, which means that essentially this number is essentially some number between a 400 and a 500, and of course it's a 410 is much closer to a 400, which means that then you would round the number down to essentially to a 400, right? And so basically another way to think of the same thing is that essentially a 410, you want to round it to the nearest hundreds, right? Which is essentially this place value over here, right? Now you will take a look at essentially the digit to the right of that, to the right of the digit 4, right? Essentially you want to, essentially the number is 410, right? And you want to round to the nearest hundreds, which means that you want to round to this digit 4, right? And then essentially what you will do is that you will basically take a look at the digit to the right of the digit 4, okay? And since it's some number essentially like 0, 1, 2, 3, 4, 3, and 4, then of course you will have to round down. Rounding down means that essentially the digit 4 over here is not going to be incremented, which means that the digit 4 remains the same, and then essentially the rest of the digits in the number are going to be substituted with zeros basically, which means that essentially then the number is going to be essentially 400, right? Or for example, let's say that for example you have the number 889. You have the number 889, and you want to round it to the nearest hundreds again. So how do you do that? The nearest hundreds, essentially what that means is that basically you want to round the number to this to this digit over here, because that's the ones place value, the tens place value, and then the hundreds place value, right? So then you want to essentially round to this digit over here. So again, you will, and well, of course, there is two ways that you can do this, whichever one is easier for you. Essentially, you know that essentially 889 is some number between essentially 800 and essentially 900, right? And 889 is essentially very close to 889 is very close to essentially 890, and 890 is very close to 900, right? So then you could just simply round up and essentially take essentially to 900. Another way that you can do this is that essentially you want to round to this digit 8, right? So then you will take a look at the digit to the right of it, which is essentially a digit like 5, 6, 7, 8, essentially the larger digits, which means that then you are supposed to round up basically. Rounding up means that essentially this digit 8 is going to be incremented, which means that it becomes a 9, and then the rest of the digits in the number are going to be essentially substituted with zeros, which means that then you will end up with the 900. So any way that you do it, you're going to end up with the same thing. Now there is another, basically let's consider another example over here, which is essentially, let's consider essentially all the numbers essentially 1 to basically 49, and essentially all numbers essentially 51 to 99, if I'm not mistaken. So 1 to 49, 59 to 99, and you want to essentially to round all of these numbers to the nearest hundreds basically, right? Now you see that essentially if you take a look at these numbers on a number line, if I take this as a 0, and if I go all the way up to essentially to 100 over here, and if I take this for example as a 50 for example, then the numbers 1 to 49 would be essentially in this area over here. So that's 1 to 49, and 51 to 99 would be right over here, right? So you see that essentially all of these numbers are much closer to 0 than to essentially to 100. So then essentially all of these numbers you would just simply round them down to a 0, right? And then all of these numbers are essentially much closer to 100 than they are to 0. So then all of these numbers then would be rounded up essentially to 100, which means that essentially now of course for example if I consider a 1 over here, and if I were to round it to the nearest hundreds basically, what I have over here is that, so of course the hundreds place value doesn't even exist in this number, meaning that it's a 0 basically, and there is a 0 over here. So the hundreds place value in this number is actually a 0, right? And and the number is essentially, the number, when you consider it this way, the number is much closer to a 0. So then you would essentially all of these numbers, you would just simply round them down to 0, and we have no problems over here. But again over here essentially with these numbers, which is essentially 51 to 99, for example with the 51 you have the ones place value, you have the tens place value, but then again the hundreds place value is basically a 0, right? And you want to essentially round to the hundreds place value, to the nearest hundreds basically. So if I take a look at the next digit, which is essentially a 5, so we said that essentially the digits 5, 6, 7, 8, and 9, we will round up basically. So I will round up, meaning that this 0 is incremented by 1, which means that it becomes a 1, and then the rest of the digits in the number become 0, right? And so essentially then a 51 is rounded up to 100. A 52 is rounded up to 100. A 53 is rounded up to 100. All the way up to 99, which is basically rounded up to 100, right? And as you can see over here, it says that basically numbers 1 to 49 are closer to 0 than they are to 100, and so they are rounded off to 0. And numbers 51 to 99 are closer to 100 than to 0, and so they are rounded off to 100. And number 50 again is equidistant from 0 and 100, and so as common practice, essentially we will round it off essentially as 100, meaning that we will essentially round up, right? Now let's take a look at a couple of these examples. So we have, for example, we have a couple of numbers over here, and they have been rounded off, and we want to know whether essentially this is correct or not. So over here, essentially, for example, we have, let me put this on a sheet of paper, or essentially, let me write it down. So we have essentially an 841, I have an 841, which has been rounded essentially as an 800. And you know that essentially 841 is essentially a number between, well, if you were to round it to the nearest, basically to the nearest hundreds, which is, I suppose, what is being done here. So then the number is essentially some number between essentially 800 and essentially 900, right? And of course, because it's much closer to 800, then you would round down to 800, and of course that's the correct way of rounding. Or basically a 2546, and it's been rounded to 2500, which is correct, rounding to the nearest basically hundreds, which is this digit over here. The number is essentially essentially somewhere between 2500 and basically 2600, and of course the number is much closer to 2500, so then you would just simply round down to 2500. Or essentially any of these, if you want to round them down, essentially round them using the digits, you could just simply say that essentially 2546, you want to round to this digit, meaning to the nearest hundreds. So you will take a look at the next digit basically to the right hand side, and since it's one of those numbers 0, 1, 2, 3, and 4 basically, then essentially then you will round down basically, meaning that this digit essentially remains the same, meaning that you will write your digit over here, and then all of these digits to the right hand side will be essentially substituted with 0, and all of these digits to the left, whatever they might be, you might have essentially, I don't know, like 10 digits to the left, you would write them down as they are. So that would be essentially 2500 basically, right? Now if you have, for example, something like a 168, so 168 is some number between essentially a 100 and 200 basically, as far as the hundreds place value is concerned basically, right? So, and of course this is much closer to 200, so you would round it up to essentially to a 200, right? Alternatively, you could take a look at the digit on the right. Since it's a 6, then you will round up, and then essentially rounding up means that essentially you'll increment this digit over here, which means that it becomes a 2, and then all of these digits to the right are to be substituted with a 0. So then this becomes essentially a 200. Right? Or for example, essentially a number like, for example, 9,537, right? And 9,537 rounded to the nearest hundreds, you will essentially, this is a 9,537, so that's a number between 9,500 and essentially 9,600. And because it's, well, because it is essentially much closer to 9,500, you will round down essentially to 9,500, right? And of course you can take a look at, the number is 9,537, so you can take a look at the digit over here. So you want to round to this digit, and you will take a look at this digit over here. Because it's essentially it's a 3, you will round down, meaning that this digit essentially remains the same, so you will write it as it is. These two digits are substituted with 0, and then this digit essentially you will write it as it is, so that's 9,500. So then the next number that we have is 286, which has been rounded to a 200, which is not right. This is wrong. And essentially when you want to essentially round the number to essentially to the nearest hundreds, which is this digit over here, if I take a look at the next digit, it's an 8. So whenever you have essentially a 5, 6, 7, 8, and 9, you will round up basically, right? Rounding up means that essentially this digit is incremented by 1, which means that it becomes a 3, and these two digits are substituted with 0. So which means that essentially your number, essentially when rounded, becomes essentially a 300, right? So, and then, for example, another example is 149, which has been rounded to essentially a 100, which is not wrong, it's right, because essentially, well, essentially 149 is some number between 100 and essentially 200, and it's much closer to, it is of course much closer to 100, which means that essentially we'll end up with 100. Another number that we have over here is a 49,730, and it's been rounded as a 49,700, right? 700. So this has been rounded to essentially to the nearest tens basically, right? This has been rounded to the nearest tens, or excuse me, to the nearest hundreds, to the nearest hundreds basically, right? So if you take a look at the next digit basically over here, so essentially this number is some number as a 40, is some number between 49,700 and 49,000 basically 800, right? And of course it's much closer to 49,700. This is of course much closer to this number, meaning that this number is much closer to this number, so I will round down and take it as 49,700, which means that the answer is correct. We have another number over here, which is a 5,750, which has been rounded as a 5,800, which is correct. Rounding to the nearest hundreds, basically the number is a 5,700, some number between 5,700 and 5,800, and of course the number is much closer to 5,800. Actually it's equidistant from the two numbers, but because we have a because we have a 5 over here, by convention essentially you will round up, which means that you will end up with a 5,800. Or another number that we have over here is a 9,870, which has been rounded as a 9,800. So rounding to this digit over here, you would round up, because there is a 7 over here. Whenever you have essentially 5, 6, 7, 8, and 9, you would round up, which means that this digit essentially is incremented by 1, becomes a 9. This 9 you would write it as it is, and then essentially these two digits you would substitute them with 0, which means that you will end up with a 9,900. And that's a 9,870, that's a 9,800, which is wrong, of course. So the answer is supposed to be the answer is supposed to be 9,870, 9,900. So this is the correct answer. Okay. Now, in the exact same way that we have been rounding these numbers up, so you can of course round your numbers to the nearest thousands by rounding up. And so we have a couple of examples over here. But then more importantly, essentially we need to consider the fact that essentially all the numbers that go, essentially if you go essentially from 0 essentially to 1,000, and halfway between the 0 and 1,000 essentially you have essentially the 500, and then we have essentially all the numbers over here which are essentially 1 through 499, and then we have essentially all the other numbers over here which are essentially 501 through 999. And of course you already know that essentially all of these numbers, when you want to round to the nearest thousands, so then essentially you can say that essentially all numbers 1 through 499, when you want to round to the nearest thousands, since they are all much essentially close to 0, you would round down to 0. Okay, so that's one thing. And then again, essentially all numbers which essentially 501 through 999, when you want to round them to the nearest thousands, since they are all closer to the 1,000, you would round up to 1,000. Now let me show you essentially one of these. You see over here, for example, 498, for example. I'm going to say 498, and I'm going to basically round to the nearest thousands. Right? Now in this number, essentially in this number, we have the 1's place value, we have the 10's place value, we have the 100's place value, and then the 1,000's place value, there is a 0 over here, right? And then basically, if I want to, and then if I take a look at the digit to the right of the 1,000's place value over here, I have this 4, and whenever you have a 0, 1, 2, 3, and 4, you will round down. Rounding down, that means that essentially you will essentially, this 0 is not going to be incremented, right? and then all of these digits are going to be substituted with a 0. So then you will get a 0. This was original 0, and then you'll get 0, 0, 0, and then 0, 0, 0, 0 is just simply a 0. So then all of these, and then by the same logic, essentially all of these numbers over here are just simply rounded down to 0. When you want to, of course, round to the nearest thousands. When you want to round, for example, to the nearest hundreds, that's a different story. Meaning that then you would end up with something like a 400, 500, something like that. But then rounding to the nearest thousands, of course, then they will all be rounded down to 0. And then all of these essentially numbers over here, for example, let's consider, for example, a 501. And you want to round this to the nearest thousands, basically. Now the thousands place value over here is the 0, right? If I look to the right of it, I have a 5 over here, which means that I have to round up by convention, right? Rounding up means that essentially this 0 is incremented to 1, and then all of these digits are basically substituted with 0, which means that then the number essentially 501 will be rounded up to 1,000 basically, right? And by the same logic, essentially all of these numbers 501 through 999 are going to be essentially rounded up essentially to 1,000. Okay, so that's basically one thing. Okay, so now let's take a look at these numbers that have been rounded here, and then we want to know whether they have been rounded correctly or not. Okay, so then what I can do is that basically, for example, the numbers are for example 2573, and you want to essentially round all of these numbers to the nearest thousands. And the nearest thousand essentially would be this place value over here. And if you take a look at the next place value, that would be a 5, which means that you would round up, which means that the 2 essentially is incremented by 1, which becomes a 3, and then all of these digits will be written as zeros. So then 2573 is rounded up to 3000. Or 6404, then essentially rounded to the nearest thousands would be essentially rounded to this place value. Take a look at the next place value, that would be essentially a 4, which means that you round down, so the 6 remains a 6, and then the rest of the digits are 0. So that's a 6,000. 7,805 rounded to the nearest thousand. Take a look at the next place value is an 8, so round up, meaning the 7 essentially becomes an 8, and then all of these digits essentially are written as 0. So that's an 8,000, which is essentially in the book it's written as a 7,000, which is of course wrong, and it has to be an 8,000. A 53,552 is written as a 53,000, which is not right, because essentially the 1,000 place value in this number is the 3,000, and then next to the 3,000 you have a 5, which means that you have to round up. Rounding up means that then essentially the 3 is incremented to become a 4, and then all of these digits are written essentially as zeros, and then the 5 is written over here as it is. So that's a 54,000, which means that the answer is actually wrong. The next number that we have is 65,437, which means that then essentially it's written as a 65,000 basically. Okay, and which is essentially the answer is right. There is nothing wrong with the answer. The thousands place value would be right over here next to the essentially to the right of it we have a 4, which means that we'll have to round down basically. So rounding down, essentially the 5 remains a 5. All of these digits are written as zeros, and then the 6 you would write it as it is. So that's a 65,000. Although essentially in all of these cases you can just simply say that, for example, 65,437 is a number between essentially a 65,000 and essentially a 66,000, right? And well, essentially you have between these two numbers you have essentially a you go essentially from you have essentially right essentially between these two numbers you have essentially 65,500, and then 437 is before 500, so that means that essentially this number is much closer to a 65,000, and so then you would round this up to essentially to a 65,000, which is the correct answer. The next number that we have is essentially a 3,499, and it's written as a 4,000, which is essentially not right, because essentially the thousands place value is right over here. To the right we have a 4, which means that you would essentially round down. So the 3 remains a 3, and all of these digits are essentially substituted with zeros. So then essentially it's not going to be a 4,000 but the 3,000 basically, right? Next, basically we have round off the given numbers to the nearest tens, hundreds, and thousands. And for example, you have the given numbers are given here, approximate to the nearest tens, hundreds, thousands, and 10,000s, and here is the rounded form. So if I have basically if I have basically 75,847, then basically approximate to the nearest tens, for example, to the nearest tens, you would have essentially the number is 75,847. The nearest tens, the tens place value is right over here, and then next to the tens place value is you have a 7, which means that you would have to round up. Rounding up means that essentially the 4 becomes a 5, and then all of these digits to the right of 4 are substituted with 0, and then all of these digits are to be written as they are. So 758. So 75,847 is rounded up to 75,850, because essentially a 47 is much closer to a 50 than a 40 basically, right? Then if you want to write the same number essentially to the nearest hundreds, then you have essentially the same number, so 75,847. The hundreds place value over here is this place value, and then to the right of it we have a 4, which means that you will essentially round down basically, which means that essentially the 8 remains the 8. All of these two digits are written as zeros, and then all of these two digits are written as they are. So they have 75,800, right? So 847, so essentially 847 essentially is much closer to 800 than 900, right? So then the 847 part, you would write it simply as an 800, and the 75,000 remains, of course, the 75,000. Now the same number nearest to the thousands, you have 75,847. The thousands place value is right over here. You take a look at the next digit, which is an 8, which means that you would round up. So rounding up means that essentially the 5 becomes a 6. These 3 digits are written as zeros, and then the 7 is written as 7. So that's a 76,000. And then to the nearest 10,000s, you have 75,847. 10,000s would be a 75,000. So that's a 10,000 space value. And then to the right of it we have 5. That means that which means that essentially we round up. So the 7 essentially becomes an 8. And then all of these digits are to be written essentially as 0. So that's an 80,000. So that's basically all that we have over here about basically rounding numbers. And in the next section we will talk a little bit about estimating outcomes of number situations. These are all very useful, basically essentially little pieces put together. And so we will essentially go through each and every one of them. So I'll see you in the next video, and thank you. Okay, so hello and welcome back. Now what we are going to do in this video, we are going to learn essentially how to do essentially our calculations more essentially more quickly. Basically there are essentially some calculations that you just simply do in your head, and those are not, I mean, not all of them are supposed to be 100% accurate, but you just want to quickly calculate something that I have this much money over here, I have essentially some other amount of money in some other place, and then if I put them together it might be something around this amount. It would be somewhere around this amount of money, and then essentially if I use the amount of money that I have, if I use it to essentially buy these couple of things, then I might actually even there might even be some money left or something like that, or essentially will I be able to buy all of these different items with the money that I have. You just do some sort of some quick calculation in your head, and then you have some idea essentially, and then you will proceed with your thoughts basically. Okay, so now essentially the kind of calculation that we do essentially in mathematics is usually essentially we write things down. And of course I might not have essentially talked about this enough, and essentially in learning mathematics, it's of course absolutely important that essentially that anything that you want to stay with you. Okay, anything that in mathematics you want to become a part of your mind, you have to write it down on a piece of paper with your own hand basically. Okay, it's not enough essentially. Of course the video is a great thing, you can look at it, it gives you essentially ideas, it gives you explanations, it helps you to understand all of these things. But then understanding, this kind of understanding, when you look at the video and then you think to yourself that you've understood it, this is just some sort of understanding in the air. Okay, after a while it's going to leave you. But then if you want something to stay with you, write it down. Okay, write it down with your own hands, basically, or essentially with your own hand. And of course then you can get rid of the essentially that might be some piece of paper, you can get rid of it. That's not the point. The point is that you have written it down essentially with your own hand, basically, and that's absolutely important. The next thing that is important here, as far as essentially writing things down are concerned, basically all kinds of arithmetic and calculation. For a while, basically, until you feel comfortable with calculation, you have to do all of your calculations essentially by hand, and on simple paper, essentially on a piece of paper. And don't use calculator for your calculations until you are comfortable with calculation. Then you can, then if you need to, you can essentially move to a calculator. Okay, now the kind of thing that we do essentially in mathematics is that essentially we do all of these calculations. For example, if you want to add, for example, 3,946 plus 6,579 plus 2,050, you would write them essentially in the long addition algorithm. So all of the numbers essentially you would write them in essentially in columns, in the ones column, the tens, the hundreds, and the thousands columns. And of course all of the numbers have to be written, all of the digits of each number have to be written in the right column, and then essentially you will add the numbers together and then you'll get the sum, right? Now there are essentially there are many situations in which essentially you need to find essentially the answers more quickly, and to be more specific, essentially these kinds of calculations you do in your head. For example, you go to shop, you want to buy something, and then you quickly ask the price for that item, basically whatever that might be. And then essentially you already know how much money you have, you already know how much money essentially you're supposed to give out essentially for different things, and then you already know how much money is going to be left, and then you do a quick calculation in your head, and then you know whether you can buy essentially this thing or not, basically. Okay, so these are the types of calculations that you do in your head, and these are supposed to be essentially quick calculations. So then basically over here we have essentially, for example, as an example, we have a trader is to receive money from two sources. The money he is to receive is 13,569 from one source and 26,785 from another source. So essentially all together, that's a 13 plus 26, that's a 39,000, and then another 1,000, that's essentially a little bit over 40,000 he's going to receive. Basically, he has to pay essentially 37,000 to someone else by the evening. So if he has 40,000 and he pays out 37,000, still 3,000 essentially is going to be left from that money. Basically, he rounds off the numbers to their nearest thousands and quickly works out the rough sum. Now, of course, you can do essentially you can round your numbers to essentially to suitable place values and do the calculation. But the way that, for example, and everybody has their own way of doing calculation, basically. So you have your own way, I have my own way, and they're not supposed to be the same. They're actually supposed to, I mean, your way of calculation is not necessarily going to be something that I might be comfortable with, and the way that I do calculation is most probably not comfortable to you. So you have to use your own way. I will use my own way, basically. But for example, the way that I do this calculate quickly in my head, I would say that basically, okay, so I have 13,000 over here and 26,000 over here. That's essentially a 13 and a 26 is 39. So far I have 39,000. I have something over 500 rupees over here, and again somewhere over essentially around 700 800 rupees over here, so again above 500 rupees. So 500 rupees plus 500 rupees would be essentially 8,000 rupees, and over here we have a 39,000 plus 1,000 rupees would be essentially 40,000, right? And still I might have another 200-300 rupees, which is okay. I don't need to essentially to worry about that. So I could say that with all certainty, I could say that I have essentially 40,000 rupees basically, okay, and even a little bit more. So from the 40,000 rupees I have to pay essentially 37,000 rupees. So what remains is essentially 3,000 rupees. And if I do this on a calculator, I will have basically on a calculator, basically we have 26,785 plus a 13,569. That's 40,354 as we expected. And then you subtract from this, essentially from this amount, you subtract basically 37,000 rupees, and what remains is 3,354. So then essentially the trader is good to go. Okay, now this calculation I could have done basically by rounding the numbers as well, but then the problem with rounding here is that essentially if you want to round your numbers, then you have to essentially consider many different things before essentially you round your numbers. Meaning that essentially over here I have essentially a 26,785, and then I have another 13,569, right? And this is essentially the amount of money that is coming in, and the amount of money that is going out is essentially 37,000, right? Now if I want to round these numbers, essentially almost anybody would essentially, looking at this number, would essentially round these numbers essentially to the nearest essentially thousands, which would be essentially 26,000, and then, or essentially, of course, if I were to round, I would have essentially 27,000 and a 14,000, right? And then if I add these numbers together, I will have essentially 11,1, and so that's a 41,000 rupees, right? So in reality, that the amount of money that I have is 26,785 and 13,569. If I add these numbers together, I get a 14,1. 8 plus 6 is equal to 14, and 15,1 and 13,1 and 0,1, and then 40,354 rupees. So you get a little bit more money when you round your numbers this way. You get a little bit more money than you actually have. This is the amount of money that you actually have. This is the amount that you calculated essentially by essentially rounding your numbers to the essentially to the nearest thousands, basically, right? But still, essentially here, even if you do this calculation over here, you could subtract 37,000 from this amount and you're good to go. There is no problem. But then essentially that you are going to have essentially a problem if this number is very close essentially to this number over here. Then essentially your calculation might break. Okay, which means that essentially in such a case where essentially where the number which is to be essentially subtracted from the sum is very close to the sum, then you would essentially do your rounding in a different way, meaning that you would not essentially round your numbers to the nearest thousands, you would round them to the nearest hundreds, for example, so that you can have essentially more certainty in your numbers, basically. So then if I were to round my numbers essentially to the nearest hundreds, I would write them as 26,785. I'm going to round it to essentially to an 800, and 13,569 I'm going to write it as 13,600. Okay, and then basically if I add these two together, so these two essentially these two columns over here, I've already essentially by rounding the numbers I've already gotten rid of these two columns, which means that my calculation is going to be much easier, right? And that's essentially a 14,1, that's a 0,1, and then that's a 40,400, and essentially in reality we have 40,354. So then, as you can see, when you round your numbers essentially to the nearest hundreds, then there is not much difference between an actual calculation and essentially an approximation, basically. Okay, and then you know that essentially when you subtract this 37,000 from this number, then you would even get some money left, basically, which means that essentially then you're good to go. Okay, so when it comes to rounding numbers, you need to essentially you need to analyze the situation, and then based on the situation you would round your numbers to the appropriate place value. Sometimes essentially it's okay to round your numbers to the nearest thousands. Sometimes, well, there is no way to know if that's going to work, so then you would round your numbers to the nearest hundreds. Sometimes you would even have to round your number to the nearest tens. Okay, so depending on the situation and depending on the sensitivity of the situation, then you would essentially do one of those things, basically. Okay, so then basically let's take a look at how to estimate essentially sums and differences. And as an example, we have essentially you want to find you want to estimate essentially this sum over here. You don't actually want to do the addition, you want to estimate it. And so you just simply need to take a look at the numbers, right? And if I were to get a good estimate, I would round 17,986 to 18,000, meaning that I would round it basically to the nearest thousands, basically. And 5,290 I would round it to 6,000, to 5,000, which is again rounding the same number essentially to the same place value, essentially to the nearest thousands, basically. And then 18,000 plus a 6 plus a 5,000 would be 23,000. So that's a good estimate, meaning that essentially if I take the actual, essentially the amount that we got over here is essentially 23,000. That's the estimated amount. And if you do a calculation over here, which is 17,986 plus 5,290, which is 23,276, the two numbers are not very much different. Now, it doesn't mean much when I say the two numbers are not very much different, right? So essentially the number over here is 23,000 and the number over here is 23,276. So I could say that the difference between the two numbers is 276, but then essentially 276 basically that's essentially a 276 essentially in a 23,000 basically, meaning that the 276 essentially in one context would be a very large could be a very large number, and the same 276 in another context could be considered a very, very tiny small number, right? So then if you want to know essentially how well you have estimated your operation over here, the best way, I suppose the best way that you can do it is essentially using percentages. Okay, now of course we haven't talked about percentages here, so I will talk about it briefly over here, and then we will use it in talking about these numbers. So you see basically that a percentage is what actually the concept of percentage means is that essentially it's a for example, when you say essentially, for example, a 50%, right? When you say a 50%, what that means is that essentially 50% of, for example, of some amount X, for example, right? Now, whatever the value of X is basically, then 50% of X is always going to be half of X basically, right? Meaning that 50% of X in mathematical terms would be essentially X times basically 50%, which is the same thing as X times essentially 50%. Cent means 100, right? And so essentially 50 divided by 100 is essentially a 5 divided by 10. 5 divided by 10, which is essentially 5 divided by 5 is 1, 10 divided by 5 is 2, so that's 1/2. So that's X times essentially 1/2, or essentially X over 2, right? So that's essentially half of X. So 50% of X is always going to be half of X, meaning that essentially whatever the value of X you divide essentially that X by 2, that would be essentially 50% of X. Now, when you say for example 40% of X, what that means is that essentially X times basically, for example, 40%, which is the same thing as essentially X times 40%, which is 100. That's essentially a 4 divided by a 10. So, and the way that you simplify these fractions, a 40 divided by 100, you would essentially you could write this as essentially a 4 times a 10, meaning a 4 times a 10 is a 40, and a 100 is a 10 times a 10 basically. And then the common factors in the numerator and denominator you can simply cancel out, right? Because essentially you can write this as 4 essentially over 10 times essentially a 10 over a 10, and then any number divided by itself is going to be equal to 1. So then basically instead of essentially instead of opening this statement over, or this expression over here, I'm going to essentially, you could write it this way, or you could just simply basically take the 10 over here and take the 10 over here and simplify them. Or even before essentially you come to this, you write your expression in this manner, you could just simply say that essentially that that essentially a 40 is the same thing as 4 times 10, and 100 is a 10 times 10. So the two tens basically in these two, I'm going to simplify, meaning that I divide the 40 by 10, I'll get a 4, and 100 I divide it by 10, I'll get a 10 basically. That's 4 divided by 10, which is what I got over here basically, right? And a 4 divided by 10, again, you can see that this is the same thing as essentially a 4 is a 2 times 2, and a 10 is the same thing as 5 times 2. Again, you can cancel out these common factors. You will come up with a 2 divided by 5, right? So then, instead of essentially doing this whole thing, you can still take the same thing over here, and then since there is a factor of 2 in here, and since there is a factor of 2 in here, you can essentially, the two factors of 2, you can essentially simplify them, meaning 4 divided by 2 is a 2, and 10 divided by 2 is a 5. So then the whole fraction essentially becomes 2/5 basically. The whole fraction becomes 2/5. That's essentially how you could essentially simplify any fraction basically. Okay. Now, so then a 40% of 10 would be essentially x times 40%, which is x times 40%, and then divide by 10, you would get a 4, divide by 10, you get a 10, divide by 2, you get a 2, divide by 2, you get a 5. That's essentially x times basically 2/5, right? That's 2/5 of x basically, right? So then essentially what this means is that essentially, for example, a 50% of x is always half of x, right? Or essentially a 40% of x is only 2/5 of x basically. And what that means, essentially half of x, of course you know what that means. Essentially half means you essentially take the value of x, whatever that might be, and divide it by 2. Or essentially 2/5 is the same thing as basically 0.4. So that's essentially 4/10 of a 0.4 is essentially 4/10 of essentially the value is 4/10 basically, right? Now the significance of this percentage thing that we are discussing here is that the percent, essentially a 50% of, for example, a 1, so essentially 1 times essentially a 50% is going to be essentially, since essentially the 50% is half of x basically, so then 50% of 1 would be essentially half of 1, which is essentially a half, or essentially 0.5, which is a very small number, of course, right? But then a 50% of a 20,000 times a 50%, that would be essentially half of 20,000, which is essentially 10,000, right? So then the value that comes out of a percentage depends on this number that you're essentially putting into the expression basically. So the larger the number, the larger always is going to be essentially the percentage, right? And so a 50% in the case of, for example, a 1 would be a 0.5, but then the same 50% in the case of essentially a 20,000 would be a 10,000, which is essentially many thousand times essentially the number that we got here, right? Now, because of this property of percentages, you can very well basically use them in order to understand essentially things in their own context basically. What that means is that, for example, the number that we calculated here was essentially 23,276, right? And the number that we calculated over there by estimation was a 23,000, right? Now if if I want to know essentially what percentage of so let me show you this way. So we have essentially the two numbers 23,000 over here, which is the estimated amount from our calculation basically, and 23,276 is the actual amount, right? Now in essentially when I was talking about this a few minutes ago, I said that there is not much difference between the two numbers, right? Which again is not, it doesn't mean much when you say something like that. Essentially in mathematics it doesn't mean much when you say there is not much. Even if you take the difference and say that there is, for example, only 276, essentially the difference between the two numbers is only 276, again it doesn't mean anything, because essentially 276 basically is in and of itself is not a very large number. But then when it comes essentially into a context like this, then the context is going to be very important, meaning that then based on the context, then the value of this number essentially is going to change, of course, because a 276 out of it, for example 15 million is nothing, right? But then the same 276 out of a 25,000, something like that, is going to be is then going to be essentially a much larger number basically, right? So then basically, then essentially when you want to take the context into consideration, then you can just simply use essentially the percentage, right? And so then basically what I can say is that basically the actual amount that was supposed to be the result of this calculation was 23,276, right? And then the amount that we estimated was at 23,000, right? Which means that essentially if I take the ratio of these two numbers, meaning essentially 23,000 and divided by 23,276, that essentially gives me well, of course, if I write basically at 23,276 and then divided by itself, meaning 23,276, it's going to be equal to 1, right? Because any number divided by itself is going to be equal to 1, and 1 is the same thing as 100%, right? 1 is the same thing as 100%. Now, and then if you get 100%, then that means that essentially the whole number that you were supposed to get, you have already gotten. And so then this is essentially this might have been essentially the best estimation that anybody could have made basically, right? But then when you get essentially only 23,000 out of a 23,276, then essentially you were supposed to get a 23,276, but you got only essentially 23,000, right? And then if you do the calculation over here, 23,000 divided by 23,276 is a 0.988, for example, which is something like basically, which is essentially something like, so that's a 0.988 basically, right? Which is essentially, if you round this number to essentially this place value, you would get essentially a 0.99 basically, right? And a 0.99 is essentially the same thing as 99%, or essentially a 99 basically percent, right? Because essentially a 0.99 is essentially, that's 99/100th. That's 99/100th, which is essentially a 99%, right? So that means that essentially the number that you estimated was actually essentially 99% of the actual number that you were supposed to get, which means that this is still a very good estimation, basically, meaning that there is only a 1% difference between the number that you got and the number that you were supposed to get, right? So then when I express essentially this in terms of essentially a percentage, and when I say that essentially the estimation that we made was essentially 99% of the actual amount, now this statement actually means something, as opposed to saying that this is a very good approximation, or essentially there is only so much difference between the two numbers. So those types of things actually don't mean anything in mathematics. But then when you actually take the numbers and express them in terms of essentially a percentage, then basically then you have essentially taken the whole context into consideration, and then your statement really has a lot of weight, basically. Okay, so now let's take a look at basically another calculation that we have here, and that is basically we have a 5,000. This is example number 6, and we have a 5,000. Let's see, 5,673 minus a 436, basically, right? Now if I round these numbers, for example, if I say that I round all of these numbers essentially to the for example 5,673, I round it to the nearest thousands, which would be essentially 6,000, right? And a 436, if I round it to the nearest thousands, that would be essentially a 0, right? And then the calculation essentially becomes a 6,000 minus essentially a 0, which is equal to a 6,000, right? So I started essentially with a 5,673, and I basically even subtracted something from it, and then I ended up with a number which is larger than the number that I started with, which is of course, which means that essentially this is in no way any sort of reasonable calculation. Now what I could do is that I could basically round the numbers to, instead of essentially to the thousands, to the nearest thousands, I could round them to the nearest, basically, for example, hundreds. So that would be essentially a 5,000, or essentially I could essentially take this number, for example, the 5,673, and I round this to the nearest, basically, hundreds, which gives me essentially 5,700. And then again 436, I take it and basically I round it essentially to the nearest basically hundreds, which essentially gives me a 400. And then basically this calculation, the original calculation, 5,673 minus 436 is going to be very close to essentially 5,700 minus a 400, which is the same thing as 5,300, right? And essentially the actual calculation that I was supposed to get in this case was basically 5,673 minus a 436. If I do the essentially subtraction here, if I borrow a 1 from here and then add it to this place value, I'll get a 13, and a 13 minus 6 is equal to 9. A 13 minus 6 is the same thing as 6 plus 9 is equal to 15. So 6 plus 6 is equal to 6 plus 7 is equal to 13 basically. And 6 minus 3 is equal to 3, and then 6 minus 4 is equal to 2, and then 5,237. This is the actual number, right? So I have 5,673 minus 436, which is 5,237, and then I got essentially in calculation I got a 5,300, very close essentially, which means that if I take the ratio of these two, meaning that if I write this as essentially 5,237, and if I divide that by basically by 5,300, that would be the same thing as 5,237. If I divide that by a 5,300, that would be the same thing as essentially 0.988, which is essentially, if you round it, it becomes 0.99. That's a 99%, right? Which means that essentially between these two numbers there is only 1%. There is only 1% difference basically, which means that it's a very good basically approximation. Okay, so next let's talk also a little bit about multiplication and estimating essentially products. So let's take a look at a couple of calculations over here. This is also something interesting that you can use, well, mainly essentially of course in mathematics, but then mainly in physics, in chemistry. When you're solving problems, these types of things essentially come in really handy. So let's say that you want to have we want to estimate. We want to estimate, for example, some calculation like, for example, 19 times 78, right? And 19 times 78, of course, it's not of course complicated, but then if you want to know essentially the result of this calculation, then you would have to actually either do the calculation essentially by hand, or essentially use some sort of calculator, meaning that you would say essentially a 19 times, for example, a 70 times, for example, a 78 is the same thing as 1482, and that's essentially how you can calculate it. Or you can say essentially a 19 times a 78, and then 8 times 1 is equal to 72, 8 times 1 is equal to 8, plus 1 is equal to 15, and then 7 times 63, and then 7 plus 6 is equal to 13, and then that would be essentially the same thing as 2, 8, and then 4, and then 1, 1482, if I'm not mistaken, right? So you see, it takes a little bit of time to actually go through the calculation, right? Now, sometimes essentially you want to know, you want to approximate this calculation, but you want to know essentially whether essentially basically, for example, whether the product is less than some number or essentially greater than some number, meaning essentially for some purpose you want to know, for example, whether this product is, for example, less than 2000 or, for example, greater than 2000, and then you can, based on that, using that essentially you can do something. And of course over here essentially if I write these numbers, for example, if I round this number essentially to a 20, and if I round this number essentially to an 80 basically, and then essentially 20 times 80 is the same thing as 1600, right? and so essentially the product is 1600, and you can see that essentially in rounding the numbers, the 19 I've written it as a 20, and the 78 I've written it as a basically as an 80, right? So which means that the actual calculation must be less than even 1600. And we saw over here that the actual calculation is 1482. So then basically we can say with certainty that, of course, we don't know what the calculation might be. Of course, we have calculated that here, but suppose that we hadn't calculated this over here. Now with all certainty I can say that in 19 times 78 is less than 1600, and of course with absolute certainty we can say that essentially 19 times a 78 is also less than, of course, a 2000, because if essentially if some amount is less than 1600, it's of course going to be less than a 2000, right? So that's essentially one way that you can use essentially estimation in order to say that, for example, some amount is less than some, so essentially some product is less than some amount or greater, and so on and so forth, right? Now let's take a look at another number over here. We have basically we have essentially a 63 times 182. We have a 63 times 182, right? And we want to know essentially what that is. Okay. Now if I rounded basically both of these numbers to the hundreds place value, right? Then basically a 63 rounded to the hundreds place value would be essentially 100, and essentially 182 rounded to the hundreds place value would be essentially a 200, right? And then essentially then we could say that a 63 times 182 is very close to essentially 100 times a 200, and 100 times a 200 would be essentially 20,000, right? Which must be essentially very far off, essentially compared essentially to the actual calculation that you might get if you actually did the calculation, meaning that essentially a 63 times a 182 actually is nothing but 11,466. So that's basically something like 11,466 divided that by 20,000. That's essentially 50%, meaning that essentially so that's around 11,000, the actual number, and the number that we got is 20,000, and so we got essentially 50% over here, is 57% over here, which means that essentially the actual number is only about the 50% of the estimated amount that we got, which means that essentially this is in no way any sort of good approximation, basically, right? So then what I could do is that essentially in order to make this a better approximation, I could say that essentially I have a 63 times 182, right? Now a 63, I'm going to, instead of rounding it to the hundreds place value, I'm going to round it to the tens place value, which gives me essentially a 60. And 182, I'm going to round it essentially to a let's say, for example, to the tens place value they have calculated here, which is, I suppose, not really. So to get a more reasonable estimate, we try rounding up 63 to the nearest tens, and also 182 to the nearest tens, to get 182 180, then 60 times 180 is 10,800. This is a good estimate, but not quick enough. Okay. So then what happens here, if you take essentially your 63 over here, and if you rounded that number essentially to the 10th place value, and then if you take essentially the 182, and then if you rounded that again to the 10th place value, which would be essentially 180, right? Then I could say that this is very close to essentially to a 60 times 180, which would be essentially, I'm not going to do this calculation manually over here. So 60 times 180, that's a 10,800. That's a 10,800. Now the actual calculation is very close to 11,000, and 10,800, very close. But then doing this calculation over here is not easy. As you saw, essentially I actually had to use a calculator. Okay, so this is of course a very good estimate, but then it's not going to be quick enough, and it's not going to be easy enough. So a better way to do this still would be to say that I have basically a 63 times basically 182. And now what I'm going to do is that I'm going to round this number to the nearest tens basically, which gives me a 60. And this number I'm going to round it to the nearest hundreds, not to the nearest tens, or to the nearest hundreds, which gives me essentially 200. So then this would be very close to a 60 basically times a 200. Now 6 times 2 is equal to 12, and then you have 1, 2, 3 zeros. That's a 12,000. So you see, this calculation is very easy. I mean, it doesn't take much time to set up or to do actually. And essentially the product that we got is a 12,000, and the actual product is very close to 11,000. So it's a very, very good, essentially very good estimate, also very easy, very quick, and everything about it is just perfect. Okay, so then what we learn from here is that essentially it doesn't make any sense when you have a calculation like this. For example, 63 times essentially 182. If you round both the numbers to the, for example, 182 and a 63. So this is a number with the digit in the hundredths place value. This is a number with a 0 in the hundredths place value, right? So this number is much smaller than this number. So then if I take both of these numbers and rounded them to the hundredths place value, then the calculation is going to be very far off, right? It's going to be really far off. On the other hand, if I take basically essentially the exact same two numbers, if I take the two numbers and then rounded both of them to the tens place value, then the calculation becomes unnecessarily complicated. It's going to be a good estimate, but then the calculation becomes unnecessarily complicated, right? But then what we ended up doing over here is that essentially the number with the least with the most significant figure. So essentially any number has a least significant digit and a most significant digit. So if you have essentially a, I don't know, for example, a 5-digit number over here, for example, a 2, 5, 6, 7, 3, for example. So this is the ones place value. This is the tens place value. This over here is the hundreds place value. This over here is the thousands place value. And this over here is the 10,000s place value. Right? And this over here is the 10,000s place value. So as I move essentially from the ones place value towards the left, the value essentially of each of the place values are essentially increasing and increasing and increasing. So the digit essentially which is on the far right of the number, you would essentially call it, you would call this essentially the least significant figure, or sometimes essentially you could call it the least significant digit, basically, right? Digit. And essentially the digit which is on the far left of the number, this digit over here, is essentially called the most significant digit, basically. And these are called essentially the most and the least significant digit, because essentially a 3 over here essentially adds to the value of the number only as essentially as much as 3 times 1, essentially 3 groups of 1, which is just the 3. But then a 2 over here is going to essentially a 2 over here is going to add to the value of the number as much as 2 times 10,000, which is 20,000. So this is called the most significant digit, and this digit over here is called the least significant digit. Okay. Now, of course, there is some rules and regulations over here, meaning that basically on the right hand side of the number, if you have, for example, a 2536700, then of course these 3 digits are not counted as the least significant digit. They are just simply placeholders in the number, and then not counted as the least significant digit. So then essentially the least significant digit in this number would be essentially this digit, which is in this case not on the far right side of the number, basically. Okay, so now basically what were we actually talking about over here? So so if I'm not mistaken, I lost track of what I was actually doing here. So if I'm not mistaken, so then basically the what we learned actually here was that basically you take essentially your number over here, for example 63 times 182, and then you round this number to the tens place value, which is essentially the largest place value that there is in this number, and then you take the other number and then round it essentially to the hundreds place value, which is essentially the most significant digit in the number, basically. So this number is rounded to 100 to the nearest hundreds, but then this number is essentially rounded to the nearest tens. And the reason for that is that basically this number, the largest place value in this number is the tens place value, but then the largest place value in this number is the hundreds place value. So then this number you would round it essentially to the nearest hundreds, but then this number you just simply round it to the nearest tens, right? And then that gives you essentially a 60 times 200, which is very easy to calculate and very close to essentially what we were trying to achieve, basically. So that's basically that. Now then the next thing that we have over here is 479 times an 81, basically. So let's see essentially how we can calculate this. So we have essentially we have another calculation which is essentially 81 times 479. Now again, basically now the most significant digit in this number, essentially, since the most significant digit is the tens place value, I'm going to round this number to the tens place, to the nearest tens, basically, which gives me essentially an 80, right? Now the most significant digit in this number is the hundreds place value, so I'm going to round this to the nearest hundreds, which essentially gives me essentially 500, right? So then this is going to be very close to essentially to an 80 times essentially a 500, and that's the same thing as 8 times 5 is equal to 40, and then you have 1, 2, and 3 zeros over here. That's a 40,000, right? And then if we do essentially the actual calculation over here is essentially 81 times basically 479, which is a 38,799, which is very close to 39,000, and what we got over here is essentially 40,000, very close basically. Okay. Now, a very useful way that you can essentially use these estimations essentially in multiplication is essentially to check your work when you do essentially when you actually calculate some multiplication, like for example a 37 for example times essentially an 1889 for example. That's a pretty complicated calculation, and if you were to do it by hand essentially that would take essentially a whole lot of time. Now I'm going to do this essentially on calculator. I'm going to say 1889 times basically a 37, that's 69,893. So that's 69,893. 69,893, right? 69,893. Now this is the actual this actual calculation. Now suppose that you took the time and you did essentially this calculation by hand, but you're not really sure whether you actually got the right answer, whether you made a mistake somewhere, so you want to quickly check your work. So then what I'm going to do is that I'm going to say that essentially 37 times 1889, if I round this number to 40, and if I round this number essentially to a 2000, that's 1889, very close to 2000. So I'm going to round it to the nearest thousands and round this to the nearest tens basically. And so this is going to be very close to essentially to a 40 times essentially a 2000. 4 times 2 is equal to 8, and then I have 4 zeros over here. So then the number essentially becomes essentially my estimation becomes essentially an 80,000, right? And the answer that I got over here is essentially 69,000, somewhere very close to essentially 70,000. So 70,000, 80,000. So essentially, if I did the calculation this way, well, most probably I didn't make any mistakes basically. But then if you got your answer, like for example something like if you got essentially something like essentially an 8,000 or essentially an 800,000, something like this, meaning essentially if you got essentially some answer in the order of basically 8,000 or essentially in the order of 800,000, and you see that this is 80,000, so this is essentially, this number over here is 10 times smaller than this number is 10 times larger than this number. So of course this anything in the order of 8,000 or essentially 800,000 or essentially, for example, even an 8 million, right? All of any of these answers basically, you could quickly check, and then you would know that essentially your answer is not, essentially you must have essentially made a mistake somewhere. Okay. And this is of course very, very useful essentially in physics, in electronics, in chemistry, everywhere where you go. You always have to essentially essentially calculate all kinds of numbers basically, and of course it's very easy to make mistakes because you're almost all you are almost always basically, your mind is very tired, and it's very easy to make mistakes when you're tired. Okay, so then this way essentially you can use these different ways and strategies in order to check your work. Now this is all about essentially estimation. So in this video we talked about basically this section over here, which was about estimating outcomes of numbers and situations. We talked about estimating addition. We talked about estimating subtraction, which was essentially what we did over here, sum and difference. And we talked about estimating products. And if you know essentially how to estimate products, then it's not going to be very complicated to estimate basically division. Basically it's of course the exact same thing, only the other way around. If we get to some place and if we get to some division basically, then I'll try to solve the division and then also estimate it, and essentially I will show you how the whole thing essentially is done. Okay, so I'll see you in the next video with exercise 1.3. Thank you.